Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
Thank you very much for coming, man, and thank you for bringing all this cool stuff. What is this old-timey telescope? Is that one of the ones the sailors used to use?
That's my spyglass. Yeah, this is exactly a spyglass. This thing is actually one of the most important inventions ever made, and it really is the reason I'm probably sitting here with you. It's the actual tool, not this one, but
right.
The telescope is really the machine that changed the world the most. And what's so cool about it, it acted like a lever that moved the Earth from being the center of the universe back in Galileo's time.
What year did they invent it?
The telescope was invented around the early 1600s, and there's a popular misconception that Galileo invented it, but he didn't. He actually perfected it. So he took it from 0 to 1, basically. He took this spyglass, which was really never, it's amazing. People were using eyeglasses for many years, and nobody ever thought to go take one lens, take another lens, and go like this. No one had ever done that. There was a guy, Van Leeuwenhoek, and this guy, Hans Lippershey. They had been making glass, and they were experts at making glass in the Netherlands. But Galileo heard about that, and the original devices that they were making could magnify things 2 or 3 times at most. But Galileo realized, hey, I can improve this and then do, what mankind has always dreamt of doing, use it to make money and use it for military purposes. Because with a telescope, you could see a ship in the Venetian lagoon a day or two out before it would come on shore, and you could see it from the ground. So the distance back then was stealth technology. This took away the stealth. It would be like turning off the B-2's ability to have stealth. So he improved it so much, it was just inarguable this would change the world.
So when was the eyeglass invented?
Eyeglass was invented, it's kind of cool. The eyeglass was invented in probably the late 1500s, these lenses. Wow. Glass used to be total crap. It would be like looking through a piece of ice today. These lenses are super clear and super clean, modern lenses. This isn't a great telescope, but it's illustrative, and we can use it to do things. But what was so interesting to me, it's just like a quirk of history, is when these lenses were invented. Before then, you didn't, I don't know what your vision is, but mine's about 20/20. It's getting worse as I get older, obviously.
Yeah.
But before then, there were no standards for how good a person's eyesight was, until they had, say, the Gutenberg Bible was published. So in the 1400s and 1500s, the first movable fixed type where you had a calibrated standard, where you knew how big the type font was. And you could say, well, Joe can only see something at 5 feet away that Brian can see at 10 feet away or something like that. So then they realized, hey, I can't see what Brian can see, or I can't see what Joe can see. I need some kind of augmentation. And they would put lenses on. So that was in the original direction directly from the Gutenberg Bible to glasses. And then what's so funny is the glasses then led to making a telescope. And then the telescope led to the Earth being moved away from being the center of the universe, which the Gutenberg Bible, in some connotation, suggested that we were. So there's a direct line from the Gutenberg Bible to the glasses to the telescope to then now religion is not so centralized in the age of scientific reason.
Wow. So when they first started using telescopes, what kind of power are we talking about? Like when Galileo improved upon it, you said it was like 0 to 1.
Yeah.
Like how many levels of magnification?
So a good telescope that you can get, and I always joke, I'm not a doctor, but not a real doctor, but the only prescription Dr. Keating makes is that you should buy your kid a telescope. And actually, the reason I said this is the reason I'm probably sitting here with you is because I became a scientist thanks to getting a telescope at about age 12. And you can actually see something. I know you've been to the Keck Observatories, Mauna Kea, and you've seen the night sky from there, and that is wonderful. But every single thing that Galileo saw with his 20-power telescope, which is not that much.
Not much at all.
You can get one of those, on my website. No, I'm just kidding.
But that was a big improvement.
That was a huge improvement. Because now you could see there were craters on the moon. Now you could see there were mountains on the moon. The moon wasn't this perfect crystalline sphere that the Bible and the ancients had talked about. It had flaws, imperfections. It looked like it had oceans. That's why they're called mare, seas, the sea of tranquility.
You know what really bummed me out?
What was that?
When Samsung, when they got exposed for their digital zoom for the moon. That bummed me out. I thought I was taking a real picture of the moon.
That's
I was
right.
like, this is amazing.
There's
Look what
the
my phone
flag.
can do.
There's the flag.
It looks so clear. Like, how do they do that? And then someone took a photo of a blurry photo of a moon on a screen, and it did it to that.
Yeah, exactly.
So it cleared up the image.
It ruined the
Using
illusion.
fuckery.
They should not do that. Yeah.
No, they should not do that.
So yeah, when Galileo boosted the magnification from just a few times, that was sufficient. With just a 2-power thing like a spyglass, like a toy thing, you really can't see craters on the moon. You can't see that there's other like mountains and so forth. But Galileo really, because of the telescope, invented the scientific method, of hypothesization, of observation, collecting data, refining things. And then a lot of people forget the scientific method is predicated a lot of times on serendipity. Like just, holy crap, something happens. He didn't expect to see mountains. He wasn't saying, my hypothesis is that it formed from the same planetary system as the Earth. He just saw it. Holy crap.
And what was the very best telescope that he created as he made them better?
It only went up to about 20 times because the ability to grind glass was always the limiting factor. He understood the mathematics of it, which was also part like how is what's called the lens equation. How does that work? How does light get refracted and focused, and in so doing bend and magnify light? And so he understood it mathematically and could prove it. But he also did something really cool, which people don't appreciate. The lens in this telescope, I don't know, should I show it? Jamie, tell me if it's okay. The lens in the telescope is actually bigger than this brass piece that surrounds it, okay? And that owes to Galileo's activity. So what Galileo realized is sometimes you don't want to use everything that you have. Sometimes you want to do what's called stopping down. So you have for aperture stops in photography. So when you stop down something, it does something really important. It reduces what are called systematic effects, aberrations, unwanted effects. So instead of maximizing, say, oh, I got the biggest telescope, which is what now astronomers fight about, my telescope's bigger than yours. He said, no, you want to stop it down, and that will actually improve the quality. And you can actually see this with your own fingers. So take your fingers out, Joe. Okay. Look at some light source. Look at these stars above us.
Okay.
Make a tiny little triangle with your fingers, with your 2 fingers and your thumb.
Okay.
And then go around like one of the stars up there, and you can actually see it. Pinch it down to almost a point, and you can almost see that it will magnify a tiny, tiny bit. And do you get that effect? It's very subtle. But you're actually reducing some of the rays outside of your peripheral vision, essentially, that would otherwise come in if you have any like cataracts or anything like that. So what Galileo said is, no, don't use everything you have. Actually stop it down, make it smaller, make it seem less efficient, but it actually improved the quality, not the quantity, tremendously.
And when did they first start getting them to the point where you get telescopes like the Keck Observatory?
Yeah, that was so the Keck Observatory and the modern telescopes that we use today are not this type of telescope. This is called a refracting telescope. It uses lenses. The lenses change the speed of light inside of the medium, and that causes light waves at different angles to travel through different thicknesses and travel slower, and that causes them to converge or diverge as necessary. Nowadays, this telescope was invented by this guy Hans Lippershey, and perfected by Galileo. Isaac Newton came along almost 100 years later. Actually, he was born when Galileo died in 1642. And he invented not a refracting telescope, but a reflecting telescope of the type that the Keck telescopes you've seen are. These are telescopes that use mirrors to focus the light. They can be made much bigger. They can be made much more clearer because you don't need glass. You just need highly reflective media. And crucially, they can be supported behind them. So imagine if you made the biggest telescope of this kind. I'm kind of cheap, right? So I only brought a small phone I could put on. Actually, TSA almost confiscated this today. They were like, what? The hell is this thing? Yeah, they
don't know what a telescope is?
They were like, what is this? Are you going to use it as a weapon? But they can only be made 30 times the diameter of this telescope, of this little tiny thing. The biggest refracting telescope.
So those ones that look like a garbage can in people's backyards.
Those are reflecting telescopes. The biggest refracting telescope is in Yerkes Observatory outside of Chicago or southern Wisconsin. And it is only 39 inches across. So what happens is, imagine you have a piece of glass. Over time, the glass will start to...
Is that it right there?
That's it. Perfect.
Oh, that's pretty dope. Powerful
I
Jamie.
heard Jamie's good. Wow, that is amazing.
He's the best.
So
Look at
that's
that.
Yerkes.
So
that's
that-
puny compared to what you've seen in the Keck observatories, which
Mm-hmm.
are 10 meters across, 10 times that diameter.
Interesting. And what kind of power does that one have?
So you can get a telescope that has arbitrary power. The power is not the important thing. What's important is how clear and high quality the image can be. You can have like the digital zoom. It could be when they zoom in on your phone. Say, if you zoom in, the image quality gets crappy. But even though it
Right.
says, "Oh, you've magnified it 300 times," so you can magnify arbitrarily just by choosing the right ratio of the curvature of the lens and the distance between these two lenses. But to get higher quality, that Yerkes Observatory lens started to sag, and it has other problems. Light acts, no matter what, gets distorted when it goes through a medium. It's actually getting distorted right now as it goes through the air. And you've seen this effect. Here's my second prop of the day. This is a prism. This is a prism made of just like ordinary glass, plexiglass, and that refracts light depending on its wavelength. So
This is like the kind of stuff a hippie girl would keep on her desk, right?
That's right. You can make it into a pendant for your wife. So that is changing the color. The speed of light is getting modified depending on its color as it goes through that medium. The lesson is glass affects the color of light's propagation speed, and it affects the quality of it. It's called chromatic aberration. So there's aberration because of the defects, like a crack in the glass. There's also a defect that different wavelengths or colors of light will focus at different points on your eye or on a detector. And that's bad because you want everything to come to a point focus. You want everything to be perfectly sharp and focused. And so these lenses, once they get above a certain size, they cannot be corrected for this effect.
I've actually done quite a lot of work with binoculars because I was trying to figure out what's the difference in binoculars for like outdoor activities,
Yeah.
hunting and stuff.
Yeah.
And there's such a difference when you get to the higher quality binoculars.
Yeah.
And it's really fascinating
That's
because they
right.
both have the same, they have different, like it's 10x 42. So I guess 42 would be
42 is usually the eyepiece relief. It's basically the field related to the
field of view, right? And how much light it takes in.
Yeah, and the
But
10 is the magnification.
the superior ones, when you get to like Swarovski is probably the best.
Yes.
Their glass is so clear.
Exactly.
Like if you look through a 10x binocular that's fairly cheap and inexpensive, you look at it like, yeah, it looks good, I can see it. And then you put the Swarovskis on, you're like, oh my God.
It's like headphones, right? You can get like a piece
Yes.
of, the stock headphones from your
Exactly.
iPhone, and you can get really high quality ones.
Yeah.
And so these headphones do not distort because they're premium headphones. They don't distort the different wavelengths of sound, just like the wavelengths of light or its colors. Wavelengths of sound should not be distorted, and it's harder to amplify a signal of higher frequency or a shorter wavelength. So the net effect was they realized you could only build a telescope using glass that was that big.
Wow.
But a telescope using mirrors, right now in space, we've got, the 6 meter diameter Webb telescope, which is, 6 times bigger than the Yerkes Observatory. And that's in space. That's a million miles away from the Earth. But that's built with reflecting technology. So when you see a mirror, mirrors reflect colors independently. It doesn't change the color. You don't see, I look different if I'm in a red light versus a blue light. They have no chromatic aberration. They also can be supported from behind. With our Simons Observatory, which I'm working with some amazing scientists around the world. This is a sticker for you. So this is in Chile. This is currently the world's highest operating astronomical observatory. It's at 5,200 meters, 17,200 feet above sea level. And the telescope that's pictured there is the 6 meter diameter. We call it the Large Aperture Telescope that my friend Mark Devlin.
Is this the VLT one that I keep hearing about?
No, this is the Simons. This is just called the Simons Observatory. So when our mutual friend Eric Weinstein was on last time, he talked a lot about this man James Simons, who organized and ran the math department at the State University of New York in Santa Barbara. But he's one of the most successful hedge fund managers in the world. So this is a precursor observatory. This is led by my friends Suzanne Staggs and Mark Devlin at Princeton, at Penn, irrespective, not respectively, but the other way around. And then the Simons Observatory on the left, if you go over just a tiny bit, Jamie, yeah, there it is. So if you click on the Wikipedia there it is. Those are 2 reflecting enormous 6 meter diameter mirrors. What happens is light comes in from above, from the cosmos, reflects off the one that's tilted at a 45-degree angle here, bounces up to the other one on the left, Then that shoots across here. Actually, let me try this. I'm a professor, Joe, so this won't show up on the screen. But then it goes across, and it goes into that white little chamber over there. That white chamber, like, I could sit on your back, and we would have plenty of room inside there. That's over 6.5 feet across. This is also built by Mark Devlin and his group, and detectors by my friend Suzanne Staggs at Princeton. And this is going to be the world's most sensitive and the world's highest operating observatory when we start taking data with it next year. But you see it's reflected. It's supported from the bottom. You could not do this with lenses.
And a project like this, at this magnitude, how many years does it take to construct something like this?
With or without COVID is the question.
Oh, okay, yeah.
So we started in 2016. My friend David Spergel, who's now the president of the Simons Foundation and is leading NASA's UAP task force. So I hope we can talk about that at some point.
Oh, yeah.
So David's like one of the greatest mentors I've ever had. But he and I and others, Adrian Lee at Berkeley, we decided, we want to build the world's most capable astronomical observatory, and happened to be very close and connected to James Simons. His original job was math professor at the State University of New York called Stony Brook. And he hired my father, my late father, which maybe we'll talk about later. And they were best friends for a long time. And then Jim Simons went on to become one of the most successful hedge fund managers. He quit being a math professor and said, I'm going to start trading futures and commodities. Back in the early 70s, nobody did this. And he developed algorithms that to this day still return over 30% a year on their investments. So Jim is, I think, the 26th richest man in the world. He's dedicated his fortune to two things. One, fighting autism, because it's extremely close to his heart, and two, to solving basic physics problems in science and math and chemistry and computer science. So he's not doing applied stuff. He's not trying to make technology. He's not trying to make a better iPhone or something like that. He's dedicated purely to making the advances in pure science with no application. So this experiment was started, we pitched it to him, David Spergel and I and Mark Devlin and Suzanne Staggs and Adrian Lee. We pitched it to him in 2016. And we got funding for it around that time. And since then, we've had COVID, we've had tremendous numbers of strikes and things going on in Chile. And don't forget, Chile is in the southern hemisphere. So when we had like our first wave of COVID, like they got their first wave 6 months later because it was out of phase with our seasons. It was a nightmare. And we can't just say to my graduate student, hey, come back in 2 years when the pandemic's, or come back when there's a vaccine, or do whatever you want. We instead said, no, we kept it going. And the foundation kept paying us, and we kept it going. So now we just yesterday, my colleague Adrian Lee deployed the first receiver along with Nick Galitsky, who's a professor right up the street here at UT Austin. They deployed this telescope camera, and that we're about to start taking data for the first time in our project history.
Wow, that's very exciting.
It is. It's insane.
And how much more capable is it more capable, but is it also the position that it's in terms of the altitude that it's at?
It's a lot of those things. So the altitude is 17,200 feet.
Whoa.
So when you're up there, you need oxygen. Like when you were up at Mauna Kea, I've been there a few times. Like I get out of breath if I walk up a flight of stairs at Mauna Kea. When I'm at the site in Chile, I get out of breath walking down a flight of stairs. Like, I'm not in the best shape. But
17,000
yeah.
Wow.
It's like being on the surface of Mars. You would love it because the first of all, the people there are incredible. They've been doing astronomy since 1,000 years before our country was even founded. There were people in the Inca societies, the ancient Incas. They were studying their interpretation of the cosmos. That flows through all to today, where they have prioritized astronomy as central to Chile's GDP.
Oh, wow.
It's such an amazing place to be.
That's incredible.
And so what we do there is it's such a high altitude site. You're above half the oxygen content of that we feel here near sea level in Austin. Up there, you're wearing nasal cannulas. You have to breathe pure oxygen almost all the time.
Wow.
And if you don't, you'll pass out, and we won't let you up there.
Nobody could just hang around, not even like Wim Hof, the Iceman?
He probably could, yeah. He'd have to sign a waiver before I'd let him up there.
Yeah,
but
he'd do it. I'd be happy to do that. That fucking dude be up there deep breathing on the moon.
It's got like insane ultraviolet exposure up there. You can basically, when you're up there and you look straight up here, when you're at that altitude. It's like you're looking into space, because when you're above that altitude, there's not enough water in the atmosphere to really precipitate out. Remember, you grew up in Boston. Remember some days in the past we used to get. I grew up in New York, outside of Long Island. When some days you get this thing on the news channel, on the radio, you'd hear it, you'd be so happy. It's snowing today or whatever, right? Oh, like you got a snow day. This is awesome, right? But some days they'd say, unfortunately, whatever, we were saved. It's too cold to snow. You remember, like sometimes it'd be like it's just too cold to snow, and you're like, what the hell? Why is it too cold to snow? So we wouldn't get a snow day in those cases. Sometimes the water can be, the air temperature can be so low that the water vapor can't crystallize, nucleate, and form snow. And that's what happens there a lot of the time. So it's so clear. It's incredible.
Wow.
It's the second most incredible place I've ever been.
I've never been able to recreate my experience the first time I went to the Keck Observatory. But we just caught lightning in a bottle. And I remember when we were driving up there, we had been staying on the Big Island. And we stayed on the Big Island specifically because I wanted to go to the observatory. I was like, I just want to see it. I keep hearing that it's insane. And as we were driving up the mountain, it was cloudy. I was like, oh, this sucks. We got a cloudy day. God, oh, well. We'll go up there anyway, and we'll see what it's like and look at their telescopes and all that jazz. But then you drove through the clouds. So it was so high up there that you passed through the clouds, and then it was just crystal clear. And I swear it changed my life. Like, just looking at it that way, I don't think – I knew – everyone knows that we're in space. But
right.
You don't see it that way all the time because I just don't think it's possible unless you live in some very rural area.
Well, you mentioned this. You said, it's a tragedy that we suffer from light pollution.
Yeah.
So much so, you said, that we don't even know what we don't see.
Yeah, we don't. We have no understanding of what's above us, and that the ancients used to see every single day.
Absolutely.
That's what they saw every night.
So much so that this is a beautiful picture that Jamie's showing. This is the Alma. This stands for Atacama, which is the desert that we're in. It's the driest desert on Earth. It's the highest desert on Earth because it's 5,000 meters, 17,000 feet in the Andes Mountains. And this picture is showing this band that's arcing overhead. That's the Milky Way galaxy. I'm a professional astronomer, Joe. When I go down there, I can't recognize the constellations that I know and I've known since I was 12 years old because there's no contrast. Like every star just is like blowing you away, and it's just magnified so much by the clarity and the distance and the remove from light pollution. It is a toxic. It is preventing our children from really understanding what the ancients knew. But the great thing about that shot, Jamie, if we could keep it up for just a second longer. So you see on the left there are these two smudges there. Mm-hmm. Those you can barely see from Hawaii. I don't know if you saw them. Those are called the Large and Small Magellanic Clouds. Those are satellite galaxies of the Milky Way galaxy.
Whoa.
We're in the Milky Way galaxy. We're in this disk. And what I brought here, this is a representation of the cosmic microwave background. This was made by my friends Lyman Page and David Spergel and others on the Wilkinson Microwave Anisotropy probe. This is God's view of the cosmos, if you will. So this is what you'd see if you were sensitive to microwave vision instead of optical light. So microwaves are longer than infrared light. They're longer wavelength than they're shorter than radio waves, and they're longer than infrared light, much longer than visible light. This would be your microwave constellations. In other words, if you could see, these are unchanging fixed patterns on the sky that are only visible to microwave instruments. This satellite made this image. Running across here, this orange band around it is the Milky Way, but as seen in microwaves. So you just saw it as seen in optical. So the Milky Way emits at all frequencies. You can't get rid of it because we're inside the galaxy. So this, as I say, this is as if God is like looking down. We're actually at the center of this ball here, and we're looking out of that galaxy, out towards the galaxy. But we're on one of the arms of the spiral galaxy. Yeah, there's one of the globes, and there's a little telescope. Someone's horning into my racket there. Little Planet Factory. Watch yourself. Watch yourself. I got the little telescopes and the microwave beach ball. So that's what the galaxy looks like. And what is all that schmutz? What is all that blue stuff? Like, I don't see that when you're in Mauna Kea, right? That is dust. That's dust in the Milky Way galaxy.
Put that back up, please.
Yeah. So actually, if you go back, Jamie, to the Alma picture that you showed just a second ago, the Incas were really fascinating culture, and astronomically speaking, we look at the stars. Like, I don't know how many constellations you can recognize.
There it is.
But but the Incas, they didn't use our constellations. Obviously, they didn't like say
The Big Dipper.
Yeah, the Big Dipper or
Right.
anything like that. But they instead focused on those dark blotches. Those dark blotches are not regions representing the absence of stars. Those dark blotches are obscured. There are billions of stars there, but they're obscured by clouds of dust, basically like smoke, particles of carbon, of silicon, metals. I'm going to show you in just a bit. They pollute and they obscure and make opaque the stars behind them. So the Incas could see this much more clearly. We can't see these from where we are in the northern hemisphere, but the Incas could see it. So they made their constellations shapes that they saw in those dark, dusty globules. So if you were born back then, let's see, you just had your birthday, right? So you were born back then, August 11th?
11,
Yep.
yeah.
So you're born in August. I forget what's your sign? A Libra?
Leo.
Leo. Okay. So instead of being a Leo, they would represent you by what constellation, what dust blob there was, and they had names for it. There was a toad, there was a llama. My favorite one, Joe, there was a constellation called the umbilical cord of the llama.
Whoa.
Can you imagine going to a bar, to the mothership? Hey, baby, what's your sign? I'm an umbilicus of the llama. It's just ridiculous, right? But that's what they saw.
Wow.
And that we can't see that today, not because of light pollution, but we can't see all the other things because of light pollution. But yeah, those two little smudges on the left, those are galaxies or dwarf galaxies that are bound to the dark matter and the gravitational pull of the Milky Way. They're actually satellite galaxies. They're separate from the Milky Way.
And how many stars are in those galaxies?
A couple billion. We have 100 billion at least.
Like, you know what's insane is the density of stars. That was one of the things that was so overwhelming, because I always knew there was a lot of stars, but just the density that it's as much star as it is black when you look at the sky. It's like you're seeing a different perspective, completely different perspective. It felt like I was in the cockpit of a massive spaceship.
Yeah.
Like looking at it through glass.
And when you go up there, if you probably weren't on oxygen because you're on a tour
Yeah.
or something like that.
Yeah.
If you go up a little bit higher, so I'm a pilot. I fly little planes around Southern California. But if you go above the altitude that you were at, it's legally required that you wear oxygen, or you have an oxygen provider, a pressurized plane or whatever. So you would wear a cannula if you were in like a little Cessna or something like that, and you flew, and they can get up to that altitude easily. But if you don't have oxygen on, and you go up there, next time you go up there, you look up, you close your eyes for a second, you hold your breath. I'm not suggesting this, it's not me telling you to do this, but if you do it, you'll see apparitions of the stars. It will make you feel like you're tripping. Or so I'm told. I've never tripped.
So because you're holding your breath?
Because you're oxygen deprived, the
Right.
intensity of starlight and the contrast, as you just said, between the blackness and the lightness and the points of light, it will be essentially like you're basically out of your senses. You won't be able to process it.
I wonder if we're going to get to a point with technology that we figure out how to use some sort of diffuse lighting everywhere, where we minimize light pollution, at least minimize it to the point where you do see stars.
Yeah.
I think it really is a bad thing for us. I think it's akin to people not getting sunlight in the winter. They don't do well because they don't get vitamin D.
Yeah.
I think there's something psychological, like there's a medicine to the awe-inspiring cosmos.
It's so funny you said like that. I haven't met Andrew Huberman. He used to be a professor at UC San Diego, where I am
He's
now.
the best. Love that guy.
He's
You'd love him.
He's such an amazing contributor. His whole shtick is get out in the morning, see the morning sunlight. What I want to talk to him about, because he's an expert in the eye and the physiology of the eye, as well as all the other stuff that he does on his for his laboratory, right? But I want to ask him about astronomical things. Like, we see that night sky. What will it mean to our physiology and to our psychology to have that robbed from a whole? We're doing an experiment. Nobody
Yes.
knows what will happen, as
Right.
you just said. What will happen? Will it be like sitting is the new smoking, or
Right.
sitting is the new crack, or I don't know what it is.
Yeah.
But that's the point. What will it mean? There's something deeply into the human mind. I mean, the reasons the constellations have names, right, is because there was no Netflix, right? There was no Netflix 2,000 years ago. So people identified things and they could navigate. I can sort of navigate by star. I know the constellation is incredibly, which doesn't sound so big a deal as an astronomer. You're like, but most astronomers don't really care. They don't know the constellations. Like,
Really?
One of the jokes is like, don't ask me what constellation that is. I'm an astronomer. You know? I always give them crap. I'm always like, yeah, if you were a geography professor, I'd say like, where's Mexico? He said, don't ask me. You know, it's like kind of ridiculous. But not having that experience, and just like you and I remember what it was like to have it at some level, or we can go and travel to it. People can't in LA, but they can do something, which is quite phenomenal, with the same telescope, that you can get an actual version of this. You can connect it to your smartphone. You can have a tripod. It's $50. I made a video once. I said, this is the best Christmas gift you could possibly get a kid. Because with it, you can see the same craters on the moon that Galileo saw. Light pollution does not obscure the planets. Light pollution does not make impossible. I'm not advocating for light pollution, but I'm just saying right here in the middle of Austin or in the middle of San Diego, I can see the exact same things that caused Galileo to realize that the sun is the center of the solar system, using scientific reasoning and evidence based on observation.
How good are the telescopes? Like, say, if you wanted to look at Jupiter, how much can you see?
You can see a lot. What you can see
the shape.
You can see the shape that it's a planet. Do you know what the word planet means or where it derives from?
No.
So I love etymology, and stop me if I'm nerding out too much. But planet means wanderer in Greek. Wanderer. What is it wandering against? The fixed stars. So the fact that you have names for things, I always think it's funny. Like, I'm Jewish, and we have a name for people that aren't Jewish, goyim. It's not an insult. It just means non-Jewish. It means nation. Right. Actually, Israel is a goy, which is a nation. But we're 0.2% of the world's population. Like, what the hell? Why are you making up names for? They should make names for you, right?
Right.
But we have names as astronomers. There were only 5 things they could see that would move in space, and those were the planets from Mercury, Venus. Obviously, they could see Mars and Jupiter and Saturn, but they couldn't see anything else. So they named those things the wanderers, and they wandered against the fixed stars. Now we know the stars do move, and actually the whole galaxy moves, and potentially, we'll get to this maybe later, maybe the universe in some sense could be said to be moving in a vaster landscape called the multiverse, which we can get to at a certain point. But the planets, you can see them. But what's so important is what Galileo saw. Jamie, if you could show this, it would be amazing. Galileo in the winter of 1610 in northern Italy, where he was living, he used a telescope not any better than this. In fact, this might be better because the glass is better, even though it's a Chinese piece of junk that I bought on eBay. But he was able to measure Jupiter and see it, and hopefully we can see it on the screen. And he saw it as a disk. So if you want to see planets, you can differentiate them right now by the fact that they do not scintillate, they do not sparkle, they do not twinkle twinkle like stars do, because they're extended objects that we can actually see through the same and different parts of the atmospheric column. That's what causes scintillation. Like a sniper rifle, they correct for it. They use what's called adaptive optics. That's to avoid like the thermal radiation from the Earth. Like you're shooting something, or elk or whatever, at great distance, there's thermal radiation close to the ground, and then the air is much cooler, and so you get these boundary layers of the atmosphere that causes differential refraction, which changes the color and the position of where the deer is, and that's not good, right? So they have to correct for that using what's called adaptive optics. Anyway, but the same phenomena happens for the planets. They're so big, they're so close to us. They're not bigger than the stars. Stars are massively bigger than any of our planets, including Jupiter, the biggest planet in the solar system. But because they're close to us, they don't appear to be points, and only points will twinkle. So if you want to identify a star versus a plane versus a planet, the planet will be the thing that doesn't move and doesn't twinkle. That's called scintillation. They do not scintillate the same way that stars do. So what Galileo did in January of 1610 is he made a series of observations of the planet Jupiter. He knew exactly where it was. He also invented the tripod. He was the first person these things that we just take for granted. Like, Joe, do you know that they didn't have clocks back then? There was no clock.
They couldn't measure time. Right?
They had sundials, but what are you going to do at night?
When was the first clock?
So Galileo tried to invent the first clock. It was actually part of a precursor to the Nobel Prize. It was something called the Longitude Prize. They offered a prize. I don't know if you've ever done any boating or whatever, but when you're out on the ocean, it's extremely hard to determine what your longitude is. It's easy to find your latitude. You just look for Polaris, the North Star. You measure your elevation, and that's going to complement where you are latitudinally on the axis going from South Pole to North Pole on the Earth. But it was impossible to tell where you are east to west from the prime meridian unless you had an accurate way of measuring time. So Galileo was one of the first people to try to compete to win this prize, which was worth, like $1 million back then in those days. And he tried a couple different ways to invent timepieces. But the one that he tried to settle on was this use of the planet Jupiter's moons. Jupiter has 4 moons. I came for that look, Joe. I came for that look. It's just, I can die happy. I got the look. Wow. Jupiter has 4 moons. And you can see them with this telescope. And I'm going to give this as a gift to you for your birthday.
That little tiny one?
You can see it, yeah. If Jupiter's out, you know where to look, and you kind of use a little bit of creative.
How much power is that one?
This one's about 12, 15 power.
So you could do it with 15 binoculars?
Yeah, easily. Yeah, you'll see what you'll see.
Tripod?
These 4 moons. But I wonder if Jamie, if you could find...
I'm trying to find something that wasn't great.
If you look up Starry Messenger, Galileo sketch, Jupiter. So what Galileo did is he turned the telescope to the moon in 1609, and then in 1610, there they are, Jamie, on the right with those stars.
Look at that illustration of Galileo.
That's his handwritten. And I've seen a friend of mine owns this copy, a first edition of these books, and you're looking at it, and actually
a first edition, the actual copy that he wrote on?
Not only that, yeah, the first edition, but it has his handwriting on it in pencil.
Whoa.
It's insane.
Oh my God, that's got to be worth $1 billion.
Oh, it's
Jamie, could you please go back to that? Those illustrations?
I had this thing. I think
That's the handwritten stuff?
Yeah,
oh, wow.
So I couldn't tell what this was. That's why I didn't want to bring it up.
Man, imagine having a piece of paper that guy wrote on.
Can you imagine it? So this is this is a depiction of him showing. So Galileo's the guy with the beard looking down, like Andrew Huberman, at the guy with the white
like
beard.
Got that beautiful chiseled beard.
That's right, muscular. So he's showing these Venetian senators and doge because they were in charge of the military budget. So even back then, there was a scientific military connection that he realized because Galileo was kind of a cad. He had a bunch of mistresses. He had some illegitimate children. And
How dare you, Galileo?
He had to support.
How dare you not be pure?
He had to support his brother, who's kind of a no-good-nick. But anyway, the sketches in the lower right show the planet as you will see it with this telescope. And I'll let you know when it comes out. And those 4 little dots, there was an image a couple of pages back, Jamie, that showed the planet as a disk, and then there are 4 stars. And if you go back one, I'll point it out to you. Yeah, see that thing in the lower right, Jamie? It's a Pinterest thing. I don't know if that's yeah, click on that. So here's a couple of, see it says January, well, it's hard to see. It's January 1610. That's Galileo's handwriting. Wow. And Ionis is like Jupiter, okay? So
he had shit handwriting.
Oh, I know, yeah.
I always thought people back then just wrote perfectly with feathers.
Who knew how to read it?
That's
right.
Good point. That's a very good point. So he's got like a doctor's handwriting.
Exactly. So this is his first major book. And in the upper left, you see the sketch of the moon with these giant craters on it. That
Over
crater,
there, Jimmy?
yeah. So if you go back,
Yeah, click on it.
So click on that, Jimmy.
That's his sketch?
That's his sketch of the moon through this telescope, essentially. Okay. Now the interesting thing is, see that big crater? That doesn't exist.
Really?
It does not exist.
The one on the top?
No, the one on the bottom.
That one.
Yep.
Doesn't exist.
Does not exist. Now, why is it there? He was a smart guy. He was he was an artist too, by the way. His father, Vincenzo, was a beautiful musician, a well-known musician. He was a sketch. I mean, this hand-drawn sketches.
Why did he put that there?
Because, Joe, he wanted to convey not only what it looked like, but how it felt. He was conveying, and when you see it, you'll feel like it's like that big, but if you actually measure it, it's about 10 times smaller than that. But
so he just made it larger than it really is.
To emphasize it. And what's so cool about that, if you want to know, you've had on like my friend Sean Carroll on, he talked about the Higgs boson when he was on the first time. If you want to feel what it was like to discover the Higgs boson, you need 10 to 20 billion euros, and you need a Large Hadron Collider. Okay, good luck. I don't know if Spotify's gonna, hook you up there. But the feeling that Galileo had, you can have that tonight. You can feel what it's like to see things for the first time in human history because it's your own history. You're experiencing it for the first time. There's no other scientific tool, nothing. Even the microscope, it's not the same viscerally. You will be connected to Galileo 400 years ago, feeling he was terrified. When he saw those pictures of those dots, he realized what he was looking at was not just like some stars that happened to be next to Jupiter. He realized he discovered another solar system, a system in which there was a massive gravitating object, Jupiter, and around it were orbiting satellites, were orbiting moons around it. Today they're called the Galilean satellites. He actually named them after his benefactor, those patrons, the Medicis, who were the richest, people in that part of northern Italy. So he was clever, right? He was trying to curry favor
Sure.
with them. It would be like if we named the whatever, the Higgs boson, we named that after, the European, equivalent of the IRS, right?
Right.
He was kind of a kiss up, in some ways, sycophant. But it had to save his life and he needed money and so forth.
Right.
But when he drew that, he realized, wait a second, the Bible and all teaching heretofore said there is only one center to the solar system, and it's the Earth, not the sun. This is called geocentrism. Everybody believed that. Aristotle, Plato, everybody had believed that for a long time because it said it was natural that heavy things should fall towards a center, and the center that everything seemed to fall towards was the center of the Earth or the Earth itself. Therefore, the Earth must be the center of the universe. Remember, the solar system was the universe for a long time. Then for an equally long time almost, the galaxy was the whole universe. And now there's the universe and maybe the multiverse that we'll talk about. So this was just incredible realization to him. Imagine like you come upon this thing and you realize you're the first person in human history ever to feel that.
Is there any documentation of his struggle with trying to convey these ideas to people that had very strong religious beliefs?
Yeah.
Because obviously it turned out to be a catastrophe for him.
That's right.
But what did he convey in his writing the frustration that he had?
He's such a fascinating person. I always make a provocative statement that like we don't need English departments. We should just teach like physics and astronomy because some of the great scientists of history, men and women, were tremendous orators. They were tremendous writers, and they could convey things through the written word that was pure artistry and mastery. And Galileo would say things like, I do not believe that the same God who has given us senses to understand the world would require that we not use them, and I'm butchering the quote, not use them in order to better understand it. He would write things that he had discovered things, only as a way to open a portal into the universe such that minds more astute than mine may be able to walk through this portal. And he was being a little falsely humble. But Newton was the same way. Newton would write as a great orator. So you can learn a lot from scientific writing. So therefore, if you only had to choose one thing, I would take the books of Galileo.
In this geocentric version of the universe that they've, how is it written in the Bible? Like, how do they describe?
It's actually, the atheist, so I call myself a practicing agnostic, which I can define later if you like. But you had on my friend Stephen C. Meyer, which is partially the reason that I'm here, I think. But to have the discussion about the influence of religion on science, and he made the claim that without religion we wouldn't have science on this show a couple of weeks ago. In other words, we wouldn't have the tradition that we can that the world is intelligible. It's not the capricious will of gods, playing with human beings as Greeks and others had identified. So the notion of how religious a scientist could be or how religion impacted him was very clear. He would say he was a very religious person. In fact, 2 of his daughters were nuns, and because of his, I always say, like, imagine we're living in a time where someone like Anthony Fauci or Francis Collins or somebody that they were not only the scientists, the expert scientists say, but they also control the government. In other words, the most powerful force on earth at that time, at least where Galileo was the Vatican. He never left Italy. He never left. Italy didn't exist back then, by the way. They were only city-states, right? Tuscany and Venice and Rome and so forth. But the notion, it was a Catholic band of jurisdiction, and Catholic Church had sway over that part of Italy and Tuscany where he was. He was very religious, but he thought that he could say things like, if he proved that something scientifically was true, he didn't understand why that couldn't be part of the religious canon. So he was surprised. In other words, he felt that the signature of God is truth. So if he discovered truth, it wouldn't be a problem it wouldn't be threatening. But I argue back then, it was kind of threatening. Like if you started having a bunch of people say, oh, the Bible's wrong, we've been misled, and they're the government, not just scientific authority, they're the government, it could lead, I'm not saying it's good, but it could lead them to want to suppress that, right? Because it could lead to insurrections, it could lead to whatever, and rebellions. And that could be perceived as very threatening to the state. But to answer your question, the Bible doesn't say anything about geocentrism. There are passages in the Bible, there's two famous ones. The most famous one is that Joshua, in the Battle of Jericho, he caused the sun to stand still. And that to many people implies that the sun was orbiting around the Earth. It certainly could be construed that way. But to answer your question, there is no real cosmology. I always say, like, let me ask you, I don't know how much, I know you've had some exposure to in Christianity, but I don't know how much you've ever read of the Old Testament, the Hebrew Bible, but the beginning of Genesis, right? So I know that you're interested in origin stories, right? So why is it that a book about, a nomadic band of Bronze Age, peasants, why does it begin with the creation of the world, of the universe? Isn't that weird? Like, shouldn't it be like, there's something really delicious that you're going to want to eat. It's called a pig. Don't eat, like, why doesn't it start with that? Why does it start with the origin of the universe?
Well, isn't that the ultimate question that man would have?
I think you're right. I think another way to interpret it is if God created the universe, then it's kind of like he has title to everything, right? He then could make a claim that, look, there's no God above me. And think about the milieu the Hebrew Bible came about in. It was pantheistic. It was in direct contradistinction to the other great religion of the time, which was, necropolism, which was basically Egypt. Egypt was a culture fixated on death. The pyramids, giant tombs. They had mummification to preserve you into the afterlife. They named everything after themselves. They had statues. Their Bible was called the Book of the Dead. In other words, in contradistinction to the Jewish Bible, the Torah is like the Book of Life, we call it. So Judaism is operating under that, where there were gods, and the gods were within nature, and they controlled man. The Hebrew Bible was meant to show that, no, God is above nature and controls nature. Therefore, the sun, everything was weird that the sun is created on the fourth day. In the Genesis description, the sun doesn't come about until the fourth day. What's day?
First?
Right. Let there be light.
Let there be light from what?
From creation ex nihilo. That's right.
Right?
The multiverse.
I mean, if it's not from the sun, there is no light.
That's right.
So what planets are we talking about?
Exactly right. So, but getting back to the original question, Galileo was very religious.
But where does it say in the Bible that the earth is the center of everything?
It's very interesting. What ended up happening was the reason it was dangerous for him, and he was accused of apostasy, was because he was claiming against the doctrine of effectively of Aristotle. And actually, Stephen Meyer taught this to me in a conference that I went to with him last year, in just a conversation. I always wondered, why is it that the Catholic Church, Catholicism branches Christianity, which came from Judaism, right? I mean, the origin of, they accept the Hebrew Bible, right? So why is it that a sect of the, or say the scientific and technological elite of the Catholic Church, why did they want to support a doctrine which really traced itself back to Aristotle, right? The Aristotelian notion was that everything was centered on the earth. Like, there's nothing in the Bible that says the earth is the center of the solar system, or doesn't say that, but Aristotle made such logical sense to the Christians, to the early Christians, and later to the Catholic Church, that they basically sanctified and made Aristotle effectively into a saint.
Wow.
And so, therefore, it was blasphemy for Galileo to contradict Aristotle.
Wow. That's incredible.
It's really strange because, Aristotle was a pagan, right? He was pantheistic, which is the number one law of the Ten Commandments, right? Is I am the Lord, you shall have no other gods before me. Meaning that Judaism came to destroy pantheism and to accept monotheism and establish it throughout the world. And now 3 billion people are affiliated with it in some way, right? So that was its key enemy. And so we didn't have a sun god. That's why if God creates the sun, God Hashem or, the God of Allah or whatever, that is more powerful than the sun. So it supersedes it. God controls the sun to do things for us and the moon to do things for us, for our benefit, not for us to worship.
That is crazy. Questioning Aristotle became blasphemy, and that's the idea of the geocentric universe.
That's right.
Wow, that's amazing. That's really amazing.
It was
Because
very
didn't they
surprising to me.
recognize that in Galileo they had essentially someone like Aristotle,
Yeah.
a very unique mind that shapes its generation and many generations to come, right in front of them, and like, no, you're committing blasphemy for being brilliant.
And you know what's amazing? Galileo has never been pardoned formally by the Catholic Church. Pope John Paul, who I
We
love.
really don't want to get into that.
So,
The Catholic Church is
but that's part of the reason
Yeah.
I became an astronomer.
interesting.
Yeah, Galileo was my hero. I got a telescope. So I was born Jewish. Both my parents are Jewish. We're Jewish. My father passed away, but they're both biologically Jewish. When I was 7, my father abandoned me and my older brother Kevin, and he started a new life. And my mother remarried an Irish Catholic man by the name of Ray Keating. And he was very devout Catholic. He's still alive, thankfully, and he lives on the East Coast. And he and his family was 10 brothers and sisters, and they welcomed me into their home and my older brother Kevin with such love and graciousness and just touching humility. And it's a big Irish Catholic family. They basically they thought that we became their biological grandchildren, cousins, nephews, and so forth. Okay, I'm still close with
That's
them.
amazing.
And I became so overawed by it. And in contradistinction to that, anything I remember about Judaism from age 0 to 7 was just like, okay, well, like you have to not eat, once you can't eat that tasty bacon. It was all things you can't do and so
Right.
forth, right? So this was like Christmas, Easter, hanging out, like just boisterous 50 cousins at Christmas. It was and so I became, at the traditional age that a Jewish boy starts learning for his bar mitzvah at age 12, I became an altar boy in the Catholic Church in Chappaqua, New York. And at the exact same time, I was saving up money to buy my first telescope, because one night I had fallen asleep and I woke up in the middle of the night, and outside the window I saw this huge bright light, and I didn't think there was a street light out there in the middle of summer looking at it, and I was like, wait, that's the moon. And there was something next to the moon that was like, it looked like a little fragment of the moon had broken off, and it was just like to the left of it. It was as bright as the moon, but much, much smaller. And I was like, what the hell? And this is in 1986. Like, there's no Google. There's no, and I remember like what it was like before the internet. So I was like, what the hell is that thing? And I had to wait until Sunday. The New York Times used to print a section called Cosmos. And in Cosmos, it would say, like, what's happening in the skies. There's going to be this, there's that. It's the first phase of the moon. And it showed a picture of the moon and some stars and, like, a map like this, but for stars. And there was a thing next to it that said Jupiter. I was like, what the hell? Like, I saw a planet. Like, I didn't know you could see a planet without a, like, Hubble space, whatever,
Right.
or without a satellite. And so I just got really interested, and I kept watching them night after night. And I was unknowingly, and I always joke, I have a pretty big ego, but I'm not going to compare myself to Galileo. But indirectly, I kept doing the things that Galileo had done, like seeing, oh, wait, the moon has craters on it. Oh, wait, the moon has mountains on it. And maybe I could measure the height of those mountains from the size of the shadow and knowing the distance to the moon. And the planet Jupiter has these 4 little dots around it, and they would change their position night to night. And like a lesser intellect like mine, not intelligent at the time, looking at it, would have just said, oh, Jupiter's just next to some stars and it's going to move, tomorrow it'll be different. But no, Galileo realized he was looking at a mini solar system edge on. He was looking, like, if you looked at above, he'd see these 4 moons going around like this, but he was looking at it like this, so they were kind of going like this back and forth, and it was periodic. And he kept doing it for night after night after night. And it kind of got boring in his book, The Sidereus Nuncius, which is otherwise an amazing book. But when you look at it, he realized, hey, it's so periodic, I could use it as a clock. So he tried to win this prize to invent the first stable, accurate clock that could be used by mariners on the ocean's surface far from land to determine the time difference between them and Greenwich, therefore determining their longitude.
And what's the mechanism that he proposed to try to measure these planets going around.
Yeah, so if you just plotted their distance over enough time, it was periodic, so you could just calculate it, just like the moon. Like,
Right, but I mean, in terms of like the actual mechanical clock itself, what was he?
So
is it just a calculated clock on paper?
You'd look up in a table like a database. He would have it printed forever, but you'd still need to see the planets and moons surrounding it. So he built, like, basically it was the first virtual reality helmet. It's called like a cellophone or something. So it was actually a helmet that you'd put on, and then it had these two short versions of his telescopes on his eyes.
Whoa.
And then, like, you'd go on the ship, and they would be moving around like this, and you'd try to do it. It failed. He didn't win it. And it would probably make you, like, totally nauseous.
Yeah. So you were wearing a helmet with telescopes in
At
the
night,
front.
in
And
the
then
ocean.
you're supposed to stare up at Jupiter and count? Like, I don't understand
You
what...
just look at the positions, and then in
That's
a
the
there
thing?
it
Is that what it looks like?
Awesome, yeah.
Wow.
Set alone. Thank you, Jamie.
That looks so crazy. If I
Can you
saw that in the
imagine?
battlefield, I'd run. Like, they have evil weapons. They have satanic weapons.
And then, first of all, you can't see the moon. You can't see Jupiter for part of the year when it's behind the sun, so that's useless.
Got a
And-
candle on.
It's got a candle.
Yeah, so
Oh
that's how
my
you can
God,
look up.
that's hilarious.
They didn't have clocks.
Right.
Forget about lights. They didn't have
So when was the
clocks.
first mechanical clock?
So the first
developed?
mechanical clocks were developed, I think, in Switzerland and in Northern Europe, Germany and Switzerland. There were wind-ups and springs and so forth. Not so. First pendulum clocks.
And what year was that around?
This was in the early 1700s. So it was finally won, I believe, the longitude prize was won in the mid 1700s.
Wow.
But actually, Galileo tried to do this from his youth. He would be in church, and I remember, even though I was an altar boy and I loved it, and I had good experiences in the Catholic Church, even though I abandoned it later on, as I'll describe. But one day Galileo was in church, and the priest was giving some boring sermon, and Galileo was just sitting there like this. And he looked up, and there was a lantern, and like some horse cart had gone through or whatever, and the lantern was going back and forth like a pendulum. And Galileo put his fingers on his pulse, and he timed the period of the pendulum, and he realized it didn't change. It was constant. And no matter what he would use for the pendulum, as long as it had the same length, it would have the same period. So all the clocks of the same, all the lanterns with the same length chain, all the chandeliers, they were all having the same periods, but those of a shorter one would go back and forth faster. So he discovered the law of pendulums, and he was like 5 years old.
Like those old grandfather clocks.
Yeah.
My grandparents used to have one of those. It
Exactly,
would
yeah.
swing. It had this brass thing.
There it is.
And it would swing.
Yep. So they have all these things. He invented the first thermometers. Jamie, if you want to look up a Galileo thermometer.
When did they how did they discern the amount of minutes in an hour, the amount of hours in a day?
So to get to a level of precision now, or then to a few minutes or a fraction of a day, that was easily significant enough to make measurements of longitude. So that the actual kind of level of precision, that didn't occur until the 1800s to get really good clocks. And now I talked to people, Bill Phillips on my podcast, the Nobel laureate at NIST, National Institute of Standards and Technology in Maryland, and they are making clocks that are accurate to 1 part in 1,000 trillionth of a second. This thing will not lose time over the age of
And
the
this
universe.
is a mechanical clock?
This is what's called an atomic clock.
Atomic
It's
clock,
optical
okay.
lattices, and they cool things down to almost absolute
wow.
zero. But the reason is the Earth used to be the Earth was the first clock, right? The Earth turns around once per day, right? And the Babylonians decided that they'd like to do it in units of 60, and even though we have 10 fingers and toes, they did it in fractions of 60 minutes, 60 seconds, 3,600 seconds in an hour.
Right, but why did they do that?
That's your game. I mean, I don't know
Really?
why they think about these things. I mean, 60 has a lot of divisors, and so it's convenient. It's divisible by 15, 12,
wonder if
10,
there was
5,
argument.
6.
I mean, when they first decided, okay, right now it's 1 o'clock. Yeah. It starts right now. Like, how do you start the day? How do you decide? Like, it's fascinating that the whole world has adopted this system,
That's
essentially,
right.
other than military, which uses a 24-hour system.
That's
But
right, yeah.
When you think about that, the whole world just decides Okay, we're all going to agree.
Yeah.
And then some places are like, fuck you with daylight savings.
Exactly.
We're not playing that game.
Arizona.
Yeah.
FL.
There's a few places like that, right?
same
Like
thing with-
Arizona doesn't do anything
They
all
don't
year.
play that game.
They're
That's
like,
right.
fuck off with your fucking pretend clocks.
We do things our way up here.
But I mean, and then, obviously there's time zones and, with traveling the way we
Yeah.
do now, it's so fascinating because you
That's
could
right.
literally fly somewhere and it's 10-hour difference in time zone.
Or like Nova Scotia, Prince
Yeah.
Edward Island, it's half hours. Got half-hour
right,
time
right,
zones up
right,
there. But
yeah.
So all this is bringing up a notion what's called calibration. So I'm an experimental physicist. The hardest thing about doing a measurement for me is not like knowing what I measure. It's knowing how I screwed up the measurement. It's like what went wrong. How do I know? Like you said, how do I know what the base level 0 point is of this measurement? What's
Right.
the calibration? When you buy this cup of coffee, when you buy the Black Rifle or the Onnit or whatever, how do you know you're getting exactly what they say? It's just printed on there, right?
Right.
So I'll ask you. You're one of the owners, right? So like, how do you ensure that? Like, have you ever thought about that? Like, do you go in and count all the atoms?
No, we had issues with that in
Yeah.
the past when we
How
first
so?
started the company. Well, we were getting stuff made in these places that do supplements. And so we were third-party testing our stuff and finding things in our supplements that weren't supposed to be in there, like different vitamins. Like, why is that in there? And then trace amounts. And it turns out it's contamination.
That's right.
And that's a lot of athletes actually get popped from small levels of steroids that are in like protein powders and creatines and things that they buy from kind of shady
Yeah, my man
organizations.
Fernando Tatis, he got nailed for that last year, right?
What does he do?
He's a San Diego Padres. He's their right fielder now. He's there.
Well, there's a lot of claims that people get popped
I know.
for that. And they get, like Canelo said, he had tainted meat from tacos. Oh, and they just happen to have steroids in them? And you look jacked as fuck?
Right,
okay,
exactly.
bro. Settle down, sir.
But the thing it does, do steroids work if you're not like going to the gym? I mean,
No,
could you,
no,
you
they do
can't
not.
it, right?
But for athletes, they have a significant advantage, and they allow you to recover much quicker. It's there's certain sports. Well, if you call bodybuilding a sport, right?
Yep.
It's
No, I do,
impossible.
definitely.
It's impossible without steroids.
some of these guys are just
Yeah, you cannot
insane,
get to
yeah.
that size. You don't get to Ronnie Coleman size. You don't get to like Dorian Yates size. You don't get there without steroids.
My mother-in-law's size. My mother-in-law, tragically, she lost her. What would have been my oldest brother-in-law when he was about 16 years old. My wife's oldest brother, and she dedicated her life to just being the best person she could be. And she built her body up. My mother-in-law, Allison. I'm like emotional thinking about her because I love her so much. And she built her body, and she did this as like a Jewish grandmother, basically.
Wow.
And she's totally ripped. I mean, she's still in great shape, but this is like 10 or 15 years ago, maybe 20 years ago. And I used to joke when I was dating my wife, Sarah, I was like, normally, like, take a girl out, scared of her father. Like, I'm terrified of your mother. She'll kick my ass. But, like, she never used to. I mean, she's, it's not her way anyway. But you can get cut, I think. You can get, like, low body fat without taking illegal stuff, probably. But you probably can't get the musculature, is what you're saying.
Oh, you can get very big without taking steroids. There's a lot of people that are massive without taking steroids. There's a lot of people that have fantastic genetics. There's a lot of people that have just thick, heavy builds. It's natural. Like there's many, many people like that. But to get to the size of a bodybuilder is superhuman. It's not possible without steroids. That is a science project. When you look at these people that have just traps that start at the top of their ears and boulders for sure, bowling ball shoulders, that's not possible. I've met many people that are really fit and look fucking huge, and they don't do steroids. There's a lot in the UFC. The UFC USADA tests everybody, so they'll show up at your house at 6:30 in the morning. Wake up, sir. We need a urine test,
sample, yeah.
and we need a blood sample, and they do that all the time. And these jacked people don't get caught. They're doing it so sophisticated that even with USADA, which is the most sophisticated anti-doping program that we have available, and very invasive, right? Because it's a real problem. Like it wakes guys up on weigh-in days and shit like that. It's not good. And they're trying to not to do that now, but you have to make sure that it's completely like you can catch them. So there's some short-acting testosterone supplements that you can take that, particularly now, apparently there's some new ones that they leave the body in like 2.5 hours. So you can take them and get an elevated level of testosterone. You could take them multiple times a day, and it doesn't affect your natural testosterone production, and it also doesn't just show up if you get past that 2.5 hour window. So there could be a lot of people who are just rolling the dice.
I see. And how do the weigh-ins work? Because one of the things I was going to mention is, to when you weigh something, like what are you comparing it
The
against?
weigh-ins are sanctioned cheating. That's what it is. It is 100%
'Cause people just
sanctioned
fast and-
legal cheating. It's more than fasting. They
Don't eat
use
blood.
very sophisticated methods. This guy, Sugar Sean O'Malley, who just won the bantamweight title, Dan Gardner is his nutritionist, and I was actually just going back and forth with him on Instagram because I watched one of the videos that he did, and I was like, that is really impressive stuff. Dan Garner is Dan. What is his profile here? It's I think it's Dan Garner Nutrition, and Garner. So he's they're detailing how they cut weight, and one of the things they do is they eliminate carbs like very close out, and they do all these different things to water load, so your body gets used to like dumping water out a lot. There's like it's very sophisticated. So when a guy weighs in this case, Sugar Sean weighed in at 135 pounds. He's 135 pounds for all of like an hour or so, and then he weighs in, and when he fights, he'll be in the 150s.
Wow.
He'll be somewhere in the 150s, and that's mild. His opponent, Aljamain Sterling, is absolutely massive for the weight class. So Aljamain, even though he weighs in at 135 pounds, he's walking around. I've seen him walking around in the 170s.
Wow, 135 is my birth weight.
He's a big. Well, he's not that small. When you stand next to him, like show an image of me standing next to him when I was interviewing him. He's fucking shredded. There's no way that guy's 135 pounds. I mean, a 135-pound person is a fairly small man.
Yeah, like
this
something
guy's
like
fucking
underweight.
jacked.
Wow.
And so it's a magic trick. The best at it is this guy, Alex Pereira. Alex Pereira, who was the middleweight champion, he weighs in at 185 pounds. He fights at 220 plus. He's so massive. Like, you cannot believe.
I'm trying to get.
Okay, so that's him on the weigh-in day. Okay, it's not him weighing in, though. So he's significantly rehydrated by that point. Is there an image of me interviewing him at the post-fight?
Is there a technique to put on weight health like safely before a fight? Like, is just drinking?
It's not
electrolytes?
safe.
It's not.
It's not safe. It's
Are you
very
think
bad.
these guys are compromising their
Yes,
lifespan? Okay.
100%. It's very bad for your organs. It's very bad for your body. But okay, so that's him. So look at that. That's 135 pounds. How the fuck?
at his
I weigh
biceps,
200.
yeah.
So look at me next to him. He's fucking gigantic. And I think he's, if not the best weight cutter in the sport, him and Pereira, they're in the running for it. Because Pereira, now show Alex Pereira. This fucking guy. This guy, you can't when he weighs in, I don't see the actual weigh-in. I go there for the ceremonial weigh-ins, and he's already put on probably 10 pounds of water by the time. So he'll weigh in first thing in the morning, and then by the time, that's him right there. Click on that link right there with me standing next to him. The one that you just had with his flexing upper right-hand corner of that one. So that's him weighing in, and his cheeks are sucked in, and he'll gain literally 40 pounds almost between them and fight night. It's fucking bananas.
They did a study, I think, in the 80s with Olympic hopefuls, and they said they made the following test to sprinters. They said, would you trade the following: a gold medal, guaranteed gold medal at the next games, if it meant you die at age 35?
They all say yes.
They all said, oh, it's like half of them said yes.
The other ones are losers.
But I've thought, but I thought about it in the context of the Nobel Prize. It's like how many scientists, have these things? Because what are these, Joe? These are, we call them like we don't think about idol worship. Like, have you ever been tempted to bow down to an idol, Joe? I mean, not
recently.
No, we have different idols, right? There's different things that we aspire to, But even people that aren't like in the religious sect, that think of themselves as atheists, let alone agnostic, or whatever, but are atheists, they all have religions.
Right.
And I think for some of these guys, yeah, I mean, if it's sacrificing your lifespan, your health span, whatever Peter or Tia would talk about, what is what's it worth? I mean, is
Right.
that high worth it? Like to be champion for a day?
Right.
Like, can you name like an Olympic sprinter from the 1980s? Besides like FloJo. I mean, there were a couple, but I don't think she said that she would trade it. But I mean, it's so transitory, and it's so applicable only to the small cadre of people within your technical network.
Right.
Like the Nobel, like you can't probably name more than you've had a couple Nobel Prize winners on the show, Sir Roger, but can you name more? No, because you're not. I can name every one. I'm just like
I could
name
name
basketball.
Penrose.
That's what I'm saying. Yeah, you know one, but you're also amongst the very few people that get to interview people
Right.
like him on a daily basis.
Yeah, it's a god to them.
Yeah.
It's this
Look at
thing
this.
that very few people achieve. Well,
So when you get this, when you win, I mean, I haven't won a Nobel Prize. I mean, my book is called "Losing the Nobel Prize," my first book, and spoiler alert, I didn't win the Nobel Prize. But
is this what it looks like?
that's a chocolate replica. Yeah, I know you won't eat that, and I hope you don't.
I'll
'cause
eat
it's
it.
15. Well, it's 15 years old, Joe. Be careful.
Why? You think it's bad? What
I'm
happens
not
to
gonna
chocolate? Would you eat it?
try it.
It would be a shame that if I ate it because it's old. Isn't that interesting? Like if you found old candy and it's still edible, like why'd you eat it? It's from the 1800s.
Honey-
it's just fucking candy.
Honey lasts forever, right? You can still
Right,
eat
it
honey in
does.
the Egyptian
Isn't
pharaohs'
that bizarre?
tombs. It's wild.
Well,
That's
yeah.
the only substance that's made by an insect, which is you're not allowed to eat insects in kosher. Jewish people aren't allowed to eat it, but it's something made by a non-kosher animal that you're allowed to eat. So it's kosher. We can eat honey even though it's made from like you can't drink pig's milk because it's made from a pig. That's not
Right.
kosher. But look at this thing. So the second commandment talks about not making graven images, or maybe it's the third. When you win a Nobel Prize, so my very close friend and mentor, Barry Barish, he won the 2017 Nobel Prize for discovering gravitational wave. He'd be an amazing guest for you, by the way, if I can have the temerity to even make such suggestions. But he invented or co-invented the LIGO experiment, which was this experiment, one branch of it's in Louisiana and one's in Washington State. 1.2 billion years ago, in a galaxy we have no idea where it is to this day, two black holes were orbiting around each other, just like Roger Penrose had predicted, and they came together, and each one was about 30 times, one was 30 times the mass of the sun, one was 32 times the mass of the sun. They combined, they made a giant black hole, even bigger, but it only had the mass of, say, 60 times the mass of the sun. So like 2 masses worth of the sun vanished, and it didn't produce light because they're black holes. And the energy supplied by them did not go anywhere else except into making what are called gravitational waves. Waves in the fabric of space-time. Such that if one were coming through this room right now, I mean, you couldn't notice it, but technically it would make your weight go up and down, like these guys on the way in would love it. It would make it go up and down, except it would take, a couple hundred days for it to even change by 1/1000th of a percent. But it changes your physical manifestation of gravity. It gives you anti-gravity for a second, and then many seconds, and then longer. It makes you heavier, lighter. That's what a wave of gravity is. It's distorting the feel and force of gravity. Well, these two black holes coalesced, and 1 or 2 sun's masses of these black holes was converted into shaking up space-time itself. Then these waves of gravity propagated from somewhere, we don't know exactly where in the universe it was. They came to the Earth. It took 1.2 billion years to get to the Earth. One instrument in Hanford, Washington State, and one instrument in Louisiana. They registered the same event, the same exact signal, but separated by the speed of light divided into the distance. In other words, these waves of gravity were traveling at the speed of light, shaking up and exactly consistent with the merger of 2 smaller black holes into one enormous black hole. Okay, so when Barry and his team, Ray Weiss and Kip Thorne, they won the Nobel Prize for this. I interviewed 15 on Thursday. I'm interviewing my 15th Nobel Prize winner, but I've interviewed 14 of them so far on my podcast. And we all, at the end of each podcast, I always ask them the same question. It's related to the name of the podcast. It's called Into the Impossible. It's a quote from Sir Arthur C. Clarke. Arthur C. Clarke said, "The only way of determining the limits of what's possible is to go beyond it into the impossible." So I always say to each guest, I say at the end, it's kind of like my wrap-up, what advice would you give yourself as a 20-year-old to give you the courage to do as you've done, to go into the impossible? And I asked Barry Barish, who's 80 years old. I said, "Barry, what would you do?" He said, "I would make sure to tell my 20-year-old self to get over the imposter syndrome because I still haven't gotten over it." So what the hell are you talking about? You won the freaking Nobel Prize. You're among there's more people in the NBA right now, Joe, than are won the Nobel Prize in physics that are alive. Okay, it's a very small group of people. At most, 3 people can win it every year. They typically win it when they're in their 70s and 80s, so their life expectancy isn't like super long. Sir Roger's 92 now, but when you win it, I said, what? How could you possibly have the imposter syndrome, this fear of inadequacy, that you don't belong where you're at, that you don't deserve the accolades that you've had? You won it. It was selected by 400 nerds in Sweden that said you are good enough to win the Nobel Prize. How could you? He said, no, Brian, when you win a Nobel Prize, you get the golden medal, like Flavor Flav, you put it on, and you get the $1 million or your portion of the $1 million purse. But they also want to make sure that you received it. You're not going to come back later and say, where's my Nobel Prize? So they make you sign a ledger. They make you sign, remember those old-fashioned autograph books? And they make you sign it. And he said, Barry told me, he said, I'm a curious guy, so what do? I look, who won it last year. I saw some of my friends and advisors maybe. Richard Feynman, wow, that's pretty cool. Marie Curie, Albert Einstein. His actual signature in this book, because it's only been around for 116 years or something like that. So goes back to Einstein. He won in 1922. When he saw Einstein, he said, I am not worthy. I'm just some humble kid from Nebraska. I don't belong here. How could I possibly be in the same book as Albert Einstein? And I said, Barry, I've got good news, and I've got good news. I said, did you know that Albert Einstein felt the imposter syndrome? He's like, you're kidding me. How could that possibly be? I said, no, Barry, he did. And I looked up this quote, and I showed it to him. I said, Albert Einstein called Isaac Newton not only the greatest scientist in history, but the man who single-handedly changed Western civilization more than any other person through the Principia and the study of natural determinism and laws. And I said, but wait, there's more. I said, Newton had the imposter syndrome. He said, you're kidding me, Newton. He was like, because Newton was kind of a prick. Newton had a huge ego. He was not kind to his friends. He tortured people as the master of the mint, or he had them tortured.
Tortured people?
Yeah, he was
physically tortured people?
Yeah, I mean, he not him.
Push that microphone so it's like in your face.
Okay, yeah.
There you go, like that.
Yeah, you'd think a podcaster.
He tortured people?
He was responsible. He was like he was responsible for the equivalent of the IRS in England. So people would cheat. They would scrape down pennies.
That's right. Yeah. I've read this.
He was the master of the mint, it was called.
Yeah, that's right.
He was also
about this.
Alchemist. He was an amazing guy, but he was kind of a prick.
And he had imposter syndrome as well.
So he had imposter syndrome. Now, who could he have imposter syndrome about? You might wonder. And if you read his writings, do you know what Isaac Newton, the creator of calculus, the first person to understand universal gravitation, discovered laws of optics, do you know what his biggest accomplishment, according to him, was?
What?
He died a virgin.
Yeah, that was a weird one, right? Yeah,
Yes.
I was going to bring that up. He was celibate.
You know why?
Why?
Because there's only one way that he could emulate his hero, the person before whom he felt the imposter syndrome. And who was that? That was Jesus Christ.
Oh, boy.
So he wanted to be Christ-like. He wanted to emulate Christ. And the only way he could do it, he couldn't fast, or I don't know, he couldn't walk on water, he couldn't turn water into wine, he couldn't turn loaves into fishes or whatever Jesus also did, but he could die celibate. And that's who he had imposter syndrome. But the lesson is...
But is this from his writing that he spoke of this?
Yeah.
Are you sure he just was like an excuse for he didn't like sex?
I don't know.
I mean, it sounds nutty. Because how do you figure that out when you're
guy.
14, 15 years old? You're young and full of hormones, and you've made this decision to be like Jesus.
Yeah. No, it's he was a strange guy.
He sounds insane.
He definitely was. He was not like Galileo.
Obviously,
you would want to hang out with Galileo if
I
you met Galileo.
I probably want to hang out with him too.
Yeah, no,
for a little bit, just to see what it's like.
So when you win the Nobel Prize, you go there, and what is the commandment about idol worship? It's that you shall make no gilded, golden, graven, like engraved images. So who is that? Do you know who that is?
Albert Nobel?
Yeah, it's Alfred Nobel. That's right.
Alfred.
And he invented dynamite, and he also died. He died never having been married. I don't know if he was celibate or
Holla.
So he was never married. But he established this prize. When you win it, you literally, the king of Sweden comes up to you, and you must bow down to him. And he puts the gilded graven image on your head. So for all the trappings and all the 90% of National Academy members who do not actively profess a belief in God, this can become at some level a religion. And it's a
Yeah.
kosher one. It's okay to worship this, right?
Well, the unattainable that's maybe perhaps attainable to a very select few is always the thing that people are chasing after, especially like high achievers.
That's right.
But many that I know that get there do have imposter syndrome, including MMA world champions. Like some of them, they get there like, this isn't real. This can't be real. I can't be the man.
Because they've set this up their whole
Yes.
life. And also, look, you can get to the promised land, but you can't stay in it. How many baseball teams have won the World Series year after year forever? I mean,
Right.
even the Yankees haven't done that. Even your Bo Sox haven't done that, right?
They're not mine.
Okay, fine. But for me, as a young kid, this is what I aspired. And actually, as an adult, I wanted to win this basically at all costs. This became but it was acceptable because people told me, like if you discover these waves of gravity manifest in the cosmic background radiation that I study, you're guaranteed to win the Nobel Prize. And for me, it was I don't know about you with your relations with your father, but I had a very difficult relationship with my father. And in it was really predicated the way that some kids would like get into fights or, with their father, or maybe they would try to be a better football player than their dad or whatever. My father was a great scientist and mathematician. And the one prize he never won was the Nobel Prize. And so after he abandoned us, this became kind of the way that I could supersede him. And it became an obsession to me, as well as being scientifically interesting to be a part of. There are very few projects that are eligible to win a Nobel Prize, let alone that can win it. But for me, it was kind of an added dimension that came with it. And that was, like the normal kid might have it with sports and their dad, or maybe the other way around with when you're a dad, you might treat your kids like that, like, oh, you think you could take me on or whatever, like. And so for that was the main source of driving impetus for my personal quest to get this particular idol in my life.
That's wild. Are you aware of Ronald Mallet? Do you know who he is?
No.
He is, I believe he's out of the University of Connecticut. He studies time travel, and he became obsessed with time travel after his father died when he was a young boy. Because he felt like if he worked hard enough, he could develop a time machine and go back and save his father.
Wow.
It's wild. It's literally a Spider-Man origin
That's
story.
exactly what I
But this
was thinking.
guy has been dedicated his life to finding a working model of a time machine. And I think, was it Kurt Gödel? Like, how do you say his name?
Gödel, yeah.
Gödel.
Mm-hmm.
It's that weird umlaut.
Umlaut.
Yeah.
Yeah.
How do you say it?
Gödel.
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 It's
Gödel.
like people that say Van Gogh, and then no, it's really Van Gogh. I'm like, excuse you.
But he developed a working model, but it just required something like the size of the solar system.
No, you're right. I don't know how you
Right.
know that. But yeah, he had a rotating cosmos where you could have what are called world lines. You could have just like you could walk around the surface of the Earth, and if you go in the same direction, eventually you'll come back to where you started. If the universe was somehow rotating in the way that he envisioned it, you could have it end up on a
There it
time
is.
start where you began from the beginning. Yeah, see
Wow.
that traveler's life like time like curve.
Wild.
Gödel's interesting because he and Einstein were buddies back at the Institute for Advanced Study, like Oppenheimer. I don't know if you saw Oppenheimer, but
I haven't seen it yet.
You should see it.
I don't go to the movies. Well, I do go to the movies. I saw Barbie.
Yeah, did it? Your girls drive you there?
I liked
My
it.
girls are not old enough to drive you there.
It's fun.
I want to say my friend Ben Shapiro, and your former guest, he hated it.
I don't understand Ben.
I
He
know.
needs to fucking have a sit down with
needs
me
to
about
chill
this.
out about that. Maybe he'll come.
But everything's a goddamn culture war.
I know.
I
That's
mean-
what I love about astronomy. No one
Yeah.
ever freaking wakes up and says,
Right.
"See that comet over there? That's a
Right.
Republican. There's
Right.
there's a Democrat astronaut." No, screw
Well,
that.
it
It's
also makes
safe.
you're studying things that are so immense and so spectacular that it makes all this stuff seem like nonsense.
That's
This
right.
stuff that people fill their days up with complaining about. But fucking Barbie movie, Jesus Christ! I mean, it would be like someone who's a pacifist reviewing the Ultimate Fighting Championship.
Exactly. There's
And saying they hit each other too much. Like, that's what it's for.
There's a joke about Einstein goes to heaven, and somebody comes up to him and says, "Oh, you're Albert Einstein. You're great. I can't wait to talk to you." And Einstein says, "First, you must tell me your IQ." And he goes, the guy goes, "I have 140 IQ." "Oh, we could talk about the math and string theory and this and that." And then another guy comes up, "Oh, what's your IQ?" It's 130. "Oh, we could talk about the stock market, and we can talk about all these, financial and then someone because I have 100 IQ. We can talk about culture wars.
I think it's more of a tribal thing than anything with us. I think what's going on is just something that's like written into the human reward system. That there's a lot of social value in being a part of a tribe. There's a lot of social value in being part of a committed ideology, whether it's a religion or a cult or
Politics.
or politics.
Well,
I
that's
think
what's
it's just
impressive. I
natural.
mean, not to be too overbearingly praiseworthy, but there's a Yiddish saying: if you stand in the middle of the road, you get hit from both sides of the street. But you seem to like defy that. And it's always interesting to me if I talk to somebody. I talk to Noam Chomsky. I personally hate his politics or whatever, but if I'm talking about linguistics and aliens and communication, I'll talk to them. But, or I talk to Ben Shapiro. People just go, oh, how could you possibly platform him?
Right.
Ben doesn't need Brian Keating's help to platform him.
That talk is nonsense. There's only one way to find the holes in someone. I mean, how many revealing interviews have you seen where people were supposedly platformed? And in those conversations, you reveal like the way that they look at the world is very flawed.
Yeah.
It's very easily pick apartable. You could just like go through it and say, well, this is illogical. This doesn't fit in with your whole philosophy of freedom. Like there's so many things that are inconsistent with the way you view this one thing. Like why do you view this one thing this way?
I think the human mind hates ambiguity, right? I mean, like no one would say like you can abort a 5-year-old. Like, I mean, I hope so. There are people. There's a guy in print. Anyway, I don't want to get into
I'm
it.
sure there's a few persons out there.
My dad used to say when I was 30, he's like, I believe in abortion up until the 33rd trimester. But on the other hand, no one say like before the parents meet, like you can't have it. Like doesn't make sense, right? So there's clear-cut benefits to being polarized because it simplifies it, gives you a hack, an algorithm. Say, I can easily say, well, you should not have an abortion. So therefore, I must be in the people that say you should never have or like gun control. Like, should you have an AK-47? Maybe. Should you have a tank-operated weapon? Probably not. Should you have a little boy? Well, you have a little boy and fat man like yourself, but it's not of that kind, right?
They're not that explosive.
So I think but it's because human beings hate these Schrodinger kind of ambiguities. They just hate them, and so they must cleave to the direction that they understand.
Yeah, it's a very unfortunate thing that doesn't get taught out of people. Instead of that, we teach them to subscribe to whatever ideology the teacher is promoting. And I think that's a real issue with people. We need to give people the space to figure out things for themselves and decide how they view all these different subjects, not have this predetermined group of questions and answers that they're a part of the ideology. You must subscribe to them wholeheartedly, wholesale.
And even by you, like apparently, so Lex mentioned that Andrew Huberman's Wikipedia page, because you platformed RF. I'm like, the guy's a Kennedy. Okay, first of all, he's Democrat. Right?
Well, this is all that happened. If you don't, Andrew Huberman commented on a post that I made about Robert Kennedy Jr. He said, "I think this is great. I hope more presidential candidates do long-form podcasts." That's it. And so Wikipedia removed the research section of his page. He's got 70 published papers.
It's highly cited.
He's very well respected, and they removed that because they had decided that they were going to. I don't know what their thought process was, what their motivation was, but it appears that what they're doing is punishing him for what he said by labeling him in a very. They're maligning him in multiple different ways.
I thought about saying like, well, you know who else Joe Rogan had on? This guy named Peter Hotez.
Yeah, well, I try to have a lot of people on.
but
it's not. There's nothing wrong with having a guy who's running for president on a podcast to discuss things. Like, what are you talking about? It's nonsense.
Yeah.
And the way they did that to Huberman, when he was just saying that he hopes more presidential candidates do long-form podcasts, you can't do that. That's tyrants do shit like that. That's horrible.
If I could, indulge your, forbearance, because how often do it's the first time I ever met you, but trying to study, how to be a better podcaster, to be better at my microscopic emulation, right? So I have on all different types of people, but sometimes I have on people, and look, I'm a scientist. I'm not a podcaster. I'm a tenured professor of physics at a major university, right? So it's not my data. But nevertheless, I feel like I owe it to people to translate what my fellow scientists are doing into layman's terms that they can understand because they pay our freaking salaries.
It's very valuable what you do. It's very valuable.
you.
It means it's so important to have people do exactly what you just described. Translate it to people that are not going to study it in any other way, and it's a very consumable way.
I get
Very
pushback.
digestible.
I said, like yesterday, a couple of days, I said on Twitter, I said, why is it that that there are science popularizers? Like, we don't have like UFC popularizers. We don't have movie popularizers. We don't have TikTok popularizers, but we have this whole class of people called science popularizers. And I'm all for it. I've talked to Neil deGrasse Tyson, Michio Kaku. I've talked to these people. It's fine. Maybe I do it at some level. Brian Cox, Brian Greene. I'm the third Brian to come on the podcast, as far as I know. But the thing is, we as scientists have been given this incredible script, the script of nature, or of God, if you will. We have this incredible present, and we are so bad at communicating what we do, and worse than that, we don't feel like it's our obligation. I always joke, and maybe it's not even a joke, scientists have a moral obligation to communicate what they do to the people that fund them, but they also have, just common sense. If the public gets turned off to science because the scientists say, I am too specialized for you, Joe. I can't break it down for an everyman to understand. What I do is I should stay in the lab because we need people that just stay in the lab and don't get out. And I always joke, like, how do you know a scientist is outgoing? Have you ever heard this one?
No.
They look at your shoes when they talk to you.
That's very funny.
But if I don't teach my students these things, if I don't teach them, look, part of the soft skills that will get you farther in life, and all the Nobel laureates that I've talked to, they all have that in common. They're not just awesome and the top elite killers of science, Joe. They're incredible communicators, persuaders, salesmen, saleswomen, because you don't just make a great idea and everyone accepts it. You have to convince people, editors, peer reviewers, funding agencies, and you're in a complex battle against the world's other killers. And what if you're just a little bit better than them because you have learned that it's important for you to communicate to your bosses, to your funding agents, such that we don't have this elite that the general public can't understand. So they just defer to whoever's, whichever way the wind's blowing, and we have what we've had for the last few years.
Well, don't you think that the reason why you have so many science influencers or science educators is because science is way more complicated than all those other things.
I don't know, is it?
Yeah.
Joe,
of course it is.
It
You don't
is
think
and it
so?
isn't.
It is and isn't?
Do you know the difference? Oh, I don't want to say it like that. I'm going to say there's a difference between complex and complicated.
Okay.
So a complicated thing is building a 787 Dreamliner. That's freaking complicated. There's over 700 million, parts to it. There's a supply chain. There's, F that. People don't know how to build a pencil. Like, there's no one person. Have you heard that? Like, that knows how to get the graphite and the wood and the eraser and the metal and the paint. There's no one person that has something as simple as a pencil could be considered but complicated means if you follow it. My PhD thesis, if you follow it, you will build a polarimeter that's capable of measuring the cosmic microwave background's polarization. Like, it's just linear steps. There's complexity. Like, if you try to make a sand pile and have exactly the same number of grains of sand, or if you want to have this particular thunderstorm that's brewing in the plains of Austin, Texas tonight, that is a complex system. That is a system that is not capable of being described by a finite number of steps. It may have properties. It may have phases. It may have building phase, dissipating phase, hail, whatever. And it may have commonalities, but like the butterfly effect, the flapping of the, you cannot replicate the sensitivity to the initial conditions that then lead to a complex event. Science can be both complicated and complex, but there's no way around this. If you can't explain it to somebody who is not an expert, you have failed at a certain level. Because just imagine if you were working do you think it's complicated to be an accountant at a top 10 accounting firm? Is that
of course?
Yeah. So imagine your boss, the CFO of that company, comes and says, "Hey, Joe Rogan, what you been working on?" You say, "What I've been working on is very complicated. It's very sophisticated. It's very complex. It's very you won't understand it." That's the implication. You're insulting the person. I'm insulting the general public. If I say, I can't explain to you why this is the frickin' absolute coolest thing in the world to do, and if you didn't pay me, or Gavin Newsom, my boss, your former governor, if he didn't pay me to do it, Joe, I would do it for free. In other words, we are so animated by it. But why don't we do it? Because actually it's the converse of what you said. Communicating to the public is hard to scientists. It's not the science that's hard to do. It's to learn how to distill it and teach it to. I've done it. I've had over 2,000 students in my career. I don't think I'm the best teacher, but I think I can do a good job enough to take somebody who was a layperson and now they're an expert. And now they're teaching down the street from me, down the street from you here, and they're much better and smarter than I am. How did that happen? If I didn't dedicate some time to it. But what scientists will say is, no, I want to study wormholes, and it's not really that important. That's the subtext. What Neil deGrasse Tyson, it's not that important. What he's doing, he can't do real. This is the rap. I'm not saying I believe this, but this is the rap. You know, he is not a real scientist. But he won't say he's not doing research. He doesn't have students. But he's not really a scientist the way that I, Brian Keating, am a scientist, because he's not actively in the trenches. Because if he were, he wouldn't have time to go out. That's BS. I'm sorry, that's BS.
Well, what I meant is that it's complicated to do in terms of
So is
like
quantum
expressing that to people. And there's so many things to cover. There's so many things, and you also have to captivate people's attentions.
Yeah.
I mean, I don't think it's, and there's also various fields of science that try explaining string theory to regular people.
You can do it.
You can, but
can
I
do
mean,
it.
it's very complicated, right?
You know, who can
It's
do
like-
it?
and
Eric Weinstein can do that. He can talk to people.
Oh, he'll put you in a coma. He will put you in a coma. I'll say, keep it simple for me, help me out, and he'll, on purpose, just.
Well, that's called that's a bias called the expert effect. Like, you're so smart, you just don't realize what it was like now. Like, you can do things in the gym, I'm sure, like, you don't even know that you're doing them, but to teach it to me would be impossible, right? Because it's just, like, encoded and viscerally into your DNA by this point.
I think I could teach you.
You could teach?
Yeah, if your body moves normal, I could teach you. Yeah.
I guess the thing is, people say, well, no, that's really not my skill set to teach in that sense. By the way, I mean, half of our jobs as professors is supposed to be to teach, not just to raise money and do research, right? So like, you'd think, well, you're a professor.
You are a science communicator, at least to a small class.
Basically, and if you're not, if you take your job seriously and you're not a schmuck, and you think that I have integrity, I'm going to learn how to do that beyond. Because what would happen if the public cut off science? If they said, we don't look what happened in the last couple of years, like, we don't know who to believe, we don't know where is the ground truth.
Right.
Who do we believe? I hear
So we're
RFK.
going to defund science.
Yeah, we're going to defund science, so you're unemployed. By the way, I only have the job I have now and not like building some weapon because we're not at war, right? I think 60 years ago in Oppenheimer, you'll watch it,
Right.
you know, like, they took the killers of science,
Right.
and they were all in the desert in Los Alamos, and they were squirreled away, and they didn't tell anybody. And,
Right.
and the same thing was going on in London and England, working on radar, and the same thing was going on in MIT. And it's just, we serve at the pleasure of the public as scientists. And when too few of us realize this, and too few of us view it as a moral obligation to communicate back to the public. And so therefore we have this industry of science popularizers, and some people make quite a good living at it.
Yeah. Well,
And got more power to them.
it's great that people are interested in it now, and it's one of the things that I think podcasts like Lex Friedman's and many other ones that platform these people and have these discussions, and it's like makes things digestible.
Absolutely.
And it's very important because it's very fascinating. I wanted to bring this thing up before I forget, because we kind of skipped over it earlier. We talked about the Webb, the Webb telescope. How old's the universe?
Okay, so you had this this tweet that took over the internet and Instagram post.
Well, it was actually something that I had heard before that.
Yeah.
Someone was saying there was something like a quasar that they had discovered that seemed to be far older than was supposed to be.
So ever since the Webb telescope was launched on Christmas Day 2021, and it's been traveling out to 1 million miles past the Earth-Moon system. It's about 1 million miles from the Earth. And there it orbits, it's cool, it orbits around a blank piece of space that orbits around the Earth and the Sun. It's a wild thing that was figured out a couple hundred years ago and is only possible to be used now. But anyway, this orbit allows James Webb and its cameras to see things in what's called the infrared portion of the infrared portion of the electromagnetic spectrum. So if you take, here I brought another GIF for Joe. So these are called a diffraction grating. So this is like 1 billion mini prisms. I got one for Jamie too. After the show, I'll give it to you, Jamie.
Okay.
So now if you hold this up to a source of white light, look at the source of white light above us. You see these beautiful rainbow halos, right? And it's almost a continuum. In other words, you can't tell where the red leaves off, the orange begins. You know, it's fuzzy, right? You can't really tell. But now look behind you at the Joe Rogan Experience neon light. Okay? You'll basically just see the yellow, you'll see the orange. And that's because that's made of gases that only emit light at very, very narrow wavelengths, very, very small wavelengths.
What am I not supposed to see?
So you don't see the halo of a pure rainbow around the O. You see a couple of colors, but you don't see the continuous. See how it kind of breaks apart?
Yeah.
Or here's another example, Joe. I'll put this on the wall. This is a laser spot. Okay. So now look at this through there. What do you see?
I can't see it.
Oh, sorry.
There you go. Oh, yeah. I see a bunch of them.
You just see a bunch of green dots.
Yeah, they're everywhere.
But now if I do this, here's a white light. I'll do it. I'll point it right closer. I don't want to blind you. But here, look at me.
Okay.
And look at that
Ooh,
light. Now you see a
pretty.
rainbow, right? Isn't that cool?
That's beautiful.
That's cool, right?
That's really pretty.
So this diffraction grating separates light out into all of its different wavelengths. It's called the spectrometer. It's dispersing it according to its color. Now, Isaac Newton and William Herschel figured out something really cool. They said, if I look at a light source, like the sun or something like that, and I block off all the light, here's the red light's on this, going to be on this side. If I put a thermometer, imagine you put a thermometer like right here. The thermometer would register 70 degrees or whatever it is in this room. If you go outside and the sun's out, it will, and the sunlight's not directly hitting the thermometer, and you put it where the red comes out over here, it starts to heat up. The thermometer gets warmer. And they realize there's light that you cannot see beyond the red that's responsible for the perception of heat. That's heat. That's called infrared radiation. If you keep going in this direction, if such a thing were possible, you eventually would get to microwaves, which is what I study. Those are wavelengths of about 1 millimeter to 3 or 4 millimeters in wavelength. Visible light is 500 millionths of a meter. It's incredibly small. Then there's infrared, et cetera, et cetera. And then finally there's radio waves way off over there that you can't see with something like this. Obviously, you can't even see infrared light with this. So they realize there's invisible light beyond the red, invisible to the eye, but visible to sensors and detectors. So what Webb has are a series of detectors like these things. These are like chips. These are actually superconductors, which I want to talk to you about this recent claim of detectors that can conduct electricity with no resistance. But these are superconductors. But nevertheless, these are like computer chips like Dell makes around the corner here, right? So if you put that, but they detect heat. Those detectors don't detect light. They don't care about light. They care about heat. So if you put them at the focus of a telescope and you spread out the light using something like this to disperse the light such that only infrared light falls on that telescope, then you will be detecting infrared radiation from whatever objects you look at. Now, if you point it at a galaxy that's far off in the distance or a quasar, that light has been red shifted. It's been moved all the way from where it started in the visible light, because those galaxies are made of suns and stars just like ours, so they should have visible light, but they're mostly red. Only the Webb telescope can see those with the kind of clarity and distinction that they're able to perceive it. Oh. What was claimed by a paper, and actually I've been communicating with the author. So one of the cool things about having a podcast is that when someone puts out a claim, like a superconductor that works at room temperature, which would revolutionize, or there's fusion, not fission, but fusion that exists now for the first time, I can call them up and say, hey, I have this fun podcast. Would you like to come on? I've had Nobel Prize winners and billionaires and whatever. And they come on and I can nerd out about science with it. It's super fun. So I did an interview with this woman, this poor friend of mine, Alison Kirkpatrick in Kansas. She was quoted as saying, like, I can't sleep, like the universe is not the way it's supposed to be. Webb has revealed and just shattered all my dreams about what the universe is really like. And this guy, I don't want to use their names, but this guy pulled that quote and said, this proves the Big Bang never happened. That was the first thing that happened after Webb came out last year. This gentleman is claiming that the universe is infinitely old, and that the reason that you see red galaxies is not because they're red shifted by the expansion of this. If I kept blowing up this beach ball, these things would be moving apart from each other, red shifting their wavelengths away from one another. He's saying, no, that's not what's happening. Instead, astronomers are foolish. They've been overwhelmed by this notion of the Big Bang. The Big Bang never happened, but light is losing energy and getting more and more red as it travels to us in an infinite universe. That's infinitely old.
Is this person qualified to make this statement?
This person has marginal qualifications. They give away the tell and poker language of this guy's non-seriousness is that he wrote the same thing 30 years ago when the Hubble telescope was launched. So he's had the same thing, and he has a book. But the second thing that you tweeted relative to was not that the universe was infinitely old, that it was twice as old as we thought.
Yeah, it's like 26
Exactly.
something billion years old.
So so I did a podcast with Alison Kirkpatrick, and she and I went through this guy's claims, and then the next day, and we showed what he was saying is slightly different. He's saying the universe has a finite age, that a Big Bang-like event happened, but because of these properties of galaxies that I'll explain in just 1 minute, because of the properties of the galaxies, the universe has to be much, much older than astronomers claimed. He doesn't say you guys are fools and idiots, and he's a legitimate professor in Ottawa. His name's Rajesh Gupta. The day after, so we went through it, took it apart. I thought it was pretty convincing, and he even agreed that there are problems with it. And worse or better, he has integrity. Let me just say that. He told me that his media office was kind of responsible for eventually leading to the tweet that you produced, because what happens in academia...
They were trying to get attention.
Well, so I call this the academia media hype complex. So ordinarily you're working on something and let's say you discover, there's this new material and it has a breaking point of 10,000 kilograms per millimeter or something. Like, okay, it's cool, it's interesting, it's important, it's incremental. No one's saying it's going to revolutionize spirituality, theology, and have our meanings restored. But it's important, okay? It's some object. But sometimes there'll be something that will be enough of a surprise that the professor, like me, will then go and say to their dean, hey, this is a cool result. I'm kind of sitting on it. I think it could be kind of big. Then the press office, we have a press office at UCSD. I've done this before. There's going to be some big news coming out about our result. It's very interesting. The university starts to promote it. Then a local newspaper, in my case, San Diego Union Tribune, in his case, the Ottawa Times or whatever, they'll start to, kind of promote it. And then if it's really provocative, it might make national news or in the physics news. And then if it's incredibly provocative, one of the world's foremost influencers might say something about it. And then Elon Musk might retweet and say that actually he thinks dark matter is even more sketchy than the age of the universe. So this in like the astronomer community just sent people into apoplexy. They were going, no, these guys should not be talking about, like I have friends, like Elon Musk shouldn't even talk about this because he launched a satellite in SpaceX whose main job is to detect dark. I'm like, what are you guys talking about? Like when lay people, and Elon's a technically minded person, he has a physics background as an undergraduate, he's not a physicist, he's not a scientist working to discover new laws of nature and employ the scientific method. He's good at engineering and he's an incredible businessman and a visionary person, but he's not. So he's kind of a proxy for a smart layman, right? In this sense, there's nothing wrong with that. But people then perceive this as like now these influencers are now overturning the work of literally thousands of astronomers and physicists working right now on legitimate scientific topics.
Let's get back to the actual claim itself.
Yeah.
So the claim itself, this is where we're getting away from this a little bit. So this claim of 26 billion years. Yeah. Does it make any sense?
So it can make sense in the following context. Imagine you see a planet, and on that planet there are people, and they're playing around with like these electrified pieces of silicon. And you'd be like, wait a second, like that's really weird. Like that planet's only 4 billion years old. How is it possible that they're not only able to talk on electrified silicon, but they're also like having an internet and space flight? No. It takes longer. In my model of how civilizations form, it must have taken 8 billion years for that to happen. So therefore, it's impossible to reconcile with the Earth being 4.3 billion years old. Therefore, the Earth must be 8 billion years old. What he said, this guy Gupta said, there are properties of galaxies. They're rotating. They're appearing too early on in the universe's early history to have developed into the spiral characteristics and the population distribution of them. Is too numerous to have occurred in a universe that's only, quote unquote, 13 billion years. And you actually said that. You said, like, I always thought, 13 billion is a pretty big number. Now they're saying 27, so what's the difference? But there's a big difference because implicit in that criticism is that there are flaws and imperfections in how we understand the Big Bang, okay? when in reality, at best, he could be correct about the formation of galaxies. But you see, those are two separate things, right? The formation and the structure of a galaxy has no bearing on how old the universe is necessarily. It tells you something about your models of computer simulations, is what he's effectively criticizing, not criticizing the evidence that something like a Big Bang occurred at a very definite point in the universe's past, that we believe to about we have equivalent precision for me to say, I know how old you are exactly, but if you looked at a 50-year-old person, you could say, the day they were born plus or minus a week. Like, that's the precision with which modern astronomers know the age of the universe. And one guy is coming up with this idea that because there's certain galaxies within it that have formed this. I mean, again, imagine if we found like a hyper advanced civilization that has warp drives and does this type 3 Dyson civilizations or whatever. They would not cast doubt on the evolution and the history of the universe itself. That would not cause me to question that. It would cause me to question my models of how people form and aliens form and stuff like that, but it wouldn't cause me to question the age of the universe. There's nothing related to it.
When we are studying the age of the universe and the vastness of space, is there potentially new technology that would expose more than we currently can view that would change your model?
In the sense that we are jobs as scientists, especially me as an experimentalist, in contrast to people like Brian Cox, Neil deGrasse Tyson, Eric Weinstein, etc., my job is not to prove theories right. My job is actually to prove them wrong. That's really what I get paid to do, is to narrow and winnow out so much so that what is left is the truth. There's a quote by Isaac Asimov. He said, if you think the Earth is flat, you're wrong. If you think it's a perfect sphere, you're also wrong, because it's not a perfect sphere. It actually bulges at the equator. It has properties, because the Earth is spinning, and the way it formed, it's a little bit like a pear, okay? So it's also not, but it's much less wrong to say it's a sphere than to say it's flat. Our job is to continually find the flaws, the cracks, that as, it said, the cracks let the light in. Right. Our job is to find the flaws in the existing paradigms, shatter those, and refine those. And there's countless examples of that throughout scientific history. So there are ways that I would be caused to doubt the formation story of galaxies. Absolutely. I mean, that's almost like predicting hurricanes. I just came through a hurricane to see you, right? There's a big hurricane in San Diego this week, and it's like an inch of rain, okay? You know how we drive in Southern California, right? So even a slick of a trace of rain causes us to go into total terror. But we didn't know where it was going to make exact landfall, because a climate is an example, as I said earlier, not of something that's merely complicated, it's complex. The best way to simulate the Earth's climate is with another Earth. In other words, there's no irreducible way to reduce the amount of complexity to describe a physical system than the system itself. That's a notion of complexity. That's a definition of complexity. So in the context of what you said, absolutely. And people like Allison and others, Kirkpatrick, they definitely would be more thrilled than anybody to discover, well, we didn't understand there's something wrong with our model of how the universe not how the universe formed, but how galaxies form.
So what I'm asking is, with the levels of detection that we have available, how significant is the change in what the Webb is able to do? And is it possible that, when we're looking, is it whatever levels of detection, whatever methods of detection we have now, is it absolute that if you go to 13 point whatever billion years, we couldn't have better methods of detection? There's no way we would get more data, more information. And would it change?
Oh, I'm sorry. Yeah. No, I misinterpreted what you said.
What I'm saying is, is it possible that with new technology we would get more information, we'd be able to see more, and then you would remap this idea?
Let me explain. Sorry, I misinterpreted what you said earlier, but now I can correct it. Yes, and the good news is that's what the Simons Observatory is trying to do. The Webb telescope was never built for, nor can it say anything about the Big Bang or what caused the Big Bang
It's
or
just galaxy formations.
it's not just, by the way. It's
That's a pretty big deal. But it's
galaxy formation, properties of stars, exoplanets, the atmospheres, the chemistry, civilizations on it can do so much cool stuff. Now, that's not my scientific, area of expertise. What I study is this: the cosmic microwave background. There are only 3 long-range messengers that can be used in astronomy. Astronomy is really hard. Unlike, say, biology. Remember in high school you had a frog or a cow's eyeball or whatever. You could dissect it. There's another frog. Like your buddy could do it better than you, and you should get the same results, right? There's multiple examples. You can do a control. Right, you can leave that frog alone and then dissect this frog and then put formaldehyde and whatever. I don't know what these biologists do, to be honest with you. But when I dissected the frog, it came back to life. I was terrible at biology, and that's what became an astronomer.
It came back to life?
It came back to... No, I'm just kidding. So you can do a variable and a control. How do you do a control when there's only one thing? Universe. There's only one cosmos, right? We can't do experiments, but what we can do is we can make use of everything that comes to us in various forms. There's only really 3 or 4 different types of things that come to us from great distances. I've brought some of those here with me today to give to you and to Jamie. So some of them are meteorites, right? There's a meteorite. So there's a meteorite. That's going to be Jamie's, so be careful with it. Now, your birthday is the peak of the Perseid meteor shower. It's one of the best meteor showers of the year typically. So next year on your birthday, I'll remind you, go out, go to a dark spot, and just look up. You don't need binoculars. You don't need a telescope. You don't need nothing. And you'll see an average a couple of meteors per hour burning up in the atmosphere. Those came from parts of our solar system, or Avi Loeb, our mutual friend, has discovered what he claims and seems to be pretty likely is fragments of a meteorite from another solar system that could potentially contain alloy. In other words, not metal. This is pure metal. So this is your birthday gift. This is one of your birthday gifts.
Oh, thank you.
So that's pretty heavy, right?
Meteorite.
That's a real meteorite. Now, how do you know it's a meteorite? So check it out. That is a fragment of the early solar system. It's actually older than the Earth. It's about 4.3 billion years old.
How do I know with a magnet?
Well, so these materials are very, very unusual in terms of their composition of relative to things on Earth. Here's a more powerful magnet.
That's more powerful than this big one?
Yeah, look at it. Yeah, that's some cheap Chinese piece of junk.
Wow, that's crazy, the difference.
Yeah, check this out. These have pull force.
This is a robbery.
That was like, yeah. So that big meteorite crashed in Argentina in about 7,000 years ago. Wow. It was found by tribesmen and tribeswomen in the 1500s, I believe. And they started to take it. And what would you do with a chunk of metal back in the 1500s, Joe?
Make swords out of it.
They made arrowheads, which you would do too, probably, right? So they just made it into weapons of war and whatnot. And then finally it was realized in the 1900s it was a meteorite.
How big was it?
It was huge, thousands and thousands of pounds, tens of thousands of pounds.
Wow.
I have one big sample even bigger than that one.
Wow.
So and I have some information for you. Now these little guys, I give these away on my website. These are because these are much, much tinier little fragments.
Those would be some very exclusive arrowheads if you get a hold of those.
Yeah. So my dream is to make these things into rings. You know how like Ryan Holiday has these like memento mori coins or whatever.
Yeah.
So my merch someday, my dream is to make these into rings or something because they look super cool. Ever seen a Rolex meteorite watch?
Yeah, the meteorite surface. That's the stone.
That's it.
Wow.
That's the rock. That's the metal chunk.
And how many years ago did this slam into the earth?
About 7,000 years ago.
Wow.
And so
that must have done a fuckload of damage.
Yeah, it was a big crater. And that's just one fragment of it. It's strewn over several kilometers, and some of the pieces are even bigger than that one.
Wow.
This is a relative. So now the Argentinian government has banned export of it. So actually you can't get these. So this is like a stockpile that I have. Yeah, I give them away, but these are fun. So we did an isotopic test on it. We found out what's the ratio of it. So these can only form in space. They have certain properties that can only form in space. So this is one of the 4 long-range messengers that come throughout the cosmos. The other one is gravitational waves. We talked about those earlier. Those travel at the speed of light. These travel 20,000 miles per hour, but it's pretty fast, but it's not speed of light, which is 186,000 miles per second. The other type of thing that travels near the speed of light, possibly at the speed of light, are called neutrinos. Neutrinos are these ghost particles that are basically almost massless. They interact with almost nothing except for other types of weakly interacting material. And then the third thing are photons. So you asked the question, could new technology reveal properties not about the age of galaxies, but the age of the universe that would cause me to question things? And that's exactly what I do. So our telescopes, the Simons Observatory, the one that I talked about earlier, it's a $110 million project, which will last over a decade. And that project is aimed at not just measuring the light. The earliest light in the universe is called the cosmic microwave background radiation. It's the leftover heat that was left over after the first atoms formed. A smallest, most simple atom, hydrogen, when it formed, there was still heat in the universe at that time. That was about 400,000 years after the Big Bang. So you can't see further back than that light, because that's when the first light is produced. Or you can't see light earlier than that. The galaxies that Webb is seeing is 300 million years old. In other words, that's from the universe is 300, so it's 1,000 times older than what we can see just with microwaves. But that's not good enough. Right? We don't want to just see the 380,000-year-old universe. We want to see it at time equals 0, or as close as we can get. Because there's some people that say there wasn't just one Big Bang. There have been multiple Big Bangs, but there are other Big Bangs going on right now. Some say there was a single Big Bang that just emerged from pure energy. Some say that there was a universe that existed before our universe, and it collapsed. And the material that would later become our universe emerged from what's called a big crunch, or a bouncing, collapsing universe. And these are different models. My job is not to prove them right. It's to eliminate whatever ones of those I can with my team, obviously. And in so doing, our new technology, which is the most cutting-edge technology ever made, and might be the last of its kind, operating in Chile, which is turning on later this year, is going to start revealing the answer to those questions. And the way that it will do that is really a combination of 3 different tools. The only 3 tools astronomers have: telescopes, detectors and telescopes, brains, that do theoretical work and make models, and then computers to simulate and to assess the data. We synthesize those 3 tools. We hope that we'll find new information. Will it change the age of the universe from 13.8 billion years to 26 billion? I don't want to say absolutely not, but there's almost no chance of that. Because it's fundamentally almost like a different type of science. It's like saying, I'm going to tell you about the age of Homo sapiens on Earth based on planetary geological forces. Like, okay, you can't have a person before there was a planet, so there's some relationship, but it's very tenuous.
Interesting.
Very tenuous.
What, if anything, can be done other than what we're doing right now to try to detect whether or not there is either signals from an intelligent species out there somewhere, or some sort of evidence of them in terms of some manipulation of their atmosphere or something like that?
Yeah, and this is obviously a big topic, and I really wouldn't have gotten so interested in it. I used to really dismiss it, and I still am. Probably you'd call me an alien minimalist, because I think there's almost no chance that there are aliens. Certainly, I would say there's almost no chance that there's intelligent technological aliens. In other words, it could be slime mold on some exoplanet Proxima Centauri b, but we never know about it because they don't have thumbs and technology, right? But I even think that might be impossible, or as close to impossible. As a good scientist, I should never say it's 0 chance they're aliens or 0. But as you go down the logical chain, as you go down the evolutionary chain of say, alien technology, as you said, could they be communicating with us? Well, we only know of these 3 different ways that they can communicate with us. The 3 things I brought here, the meteorites, they could send objects. Trash. Avi Loeb thinks these are trash. Or he went to Papua New Guinea. He scooped up some of these little fragments of a meteorite. You should definitely have him back on. It was a phenomenal episode with him. He and I had a conversation, very technical, but I like to think I can complement some of the cool stuff that you do by going deep into the astronomy, so that my colleagues actually get some interest out of it too. But when we think about craft, now you're not sending things other than sending neutrino beams to us, or sending gravitational waves to us, or sending light. Those are all things that propagate near the speed of light. This is very slow. This is very, very slow. To get this here, that took thousands and thousands of years of just orbiting around our Earth. But even if it came from another solar system, we have no idea where it came from.
Okay, I'm going to stop you
Yeah.
because you went way off track a little bit. You said, I want to be clear on what you're saying. Do you think there's no possibility for alien life in the universe?
I didn't say it's no probability. I think the probability is very low, and I can explain why.
Yeah, please.
So, have you ever heard of the Drake equation?
Yes.
Yeah. So the Drake equation is essentially a parameterization of our ignorance about certain things in the universe, and we've kind of checked off 7 of the terms and the 8 terms of the Drake equation thanks to new technology, thanks to new telescopes. How many stars have planets around them? How many total? But there's a couple terms in there: the lifetime of a civilization, and a certain fraction of how much that civilization can dedicate its energy or what have you towards broadcasting its presence, right? So for us to know that they exist, they have to they have to have made technology for them to exist, and they have to exist in the first place. So how many of such objects are? That's what the Drake equation's really parameterizing. Now, I propose that you should be able to do the following thing. If there's life in the universe, just life, slime mold, I don't care what it is,
Okay.
you should be able to set limits on it in the following sense. And what I'm going to do is do a reductio ad absurdum. I'm going to motivate, hopefully I can't prove, but I'm going to motivate the illogic of suspecting that they're extraterrestrial intelligent civilization. Okay, here it goes. Let me just tell you, my colleagues discovered that there's a planet, and it's around a star that's just like our sun. And it's next to another planet, and that planet's full of life. And the other planet's almost identical to that planet. It's almost the same size. It has a day the same age, the same length as the day of the planet that has just rotten with life. It's crawling with Kardashians and slime molds and whatever, right?
Okay.
So it's out there.
Just like us.
Yeah. And I said to you, Joe, what do you think the odds are that those two neighboring planets there's no reason physically they shouldn't both be identical? What are the odds that the other one should not have life? What would you say?
With the same environment?
It's same solar system environment, same properties. Rocky planet, had liquid water. It has an atmosphere. It has a magnetic field. Has all sorts of things.
I would think it would be more likely that it would have life.
Very likely. It
Yeah.
would be extremely likely. Okay, now let me tell you that planet exists. It's called Mars, and I brought you a piece of it here. Okay, This is a fragment. Okay, so this goes in order of expense. Okay. So these things I give away. That big meteorite is a present for you.
Thank you.
This is a piece of Mars. This I only give to you. I don't have one for Jamie.
That's an
Sorry,
actual
Jamie.
piece of Mars.
That's an actual piece of Mars.
So from an asteroid?
So what happened was the Earth gets hit by meteors, right, all the time, and but so do all the other planets. Sometimes some of that material from Mars gets impacted. Imagine something that big that Jamie showed before slamming into. It's going to eject it from the surface of Mars. That's going to orbit in the clouds of Mars. Eventually going to get outside the atmosphere of Mars if the impact is great enough, carrying some of the debris, the surface, the crust of Mars, etc. And that will then percolate throughout the solar system for tens of millions of years, perhaps, until the Earth smashes into it and it lands. In this case, it landed in Africa. That was recovered from Africa. That little third of a gram is a slice off a bigger chunk, okay? And not only does that piece of Mars doesn't have any signature of life on it, and we've been to Mars, we've stuck probes into Mars, we have a freaking helicopter flying around on Mars right now. It's insane. We don't see anything. Now, that doesn't mean that life didn't exist there before. It doesn't mean that if we don't fly into a lava cave, there won't be. But does it not say something? This is called panspermia. It's something that sounds dirty, but it's not, right?
I know the term.
Yeah. So we exchange material. And actually, Sir Fred Hoyle, the guy who came up with the idea for the name the Big Bang, he actually believed in the steady state model. He believed that's how life was seeded on Earth. The fact is that we've been exchanging material for literally billions of years, from when the Earth was, just bacteria and Mars was flowing with water. We know Mars was rich with water. Now, the fact that we don't see any, is that proof it never had? Absolutely not. But I'm just saying it's a piece of evidence And that evidence is very hard to come by, right? It's hard to prove a negative, right? It's hard to say that like Mars definitely never had life.
Can I stop you there?
Yeah.
How much detection do we have? I mean, how much technology is currently on Mars that's looking at signs of life?
There have been probes since, Viking and so forth.
How many of them are capable of detecting signs of life other than like physical
All of them have had
things?
some capability for precursors to life. In other words, some have been able to detect water. Some have had spectrometers that could detect gases.
Right,
carbon
so like
dioxide.
how many of them are landed?
Probably 15 or 20.
And Mars is, what is it? How much smaller than Earth?
It's about,
A
it's a little,
third?
yeah, it's a little bigger than the moon, but a lot
So
smaller.
it seems like a lot of space that we didn't detect things on or didn't even
right, but
visit.
But isn't that the converse of the usual argument that I hear? There's 100 billion stars in the Milky Way. Many of them are like the sun. There's 100 billion galaxies or more like the Milky Way. So it's 100 billion squared.
Right.
The universe is 13.8 billion years old. So what are the odds? So usually astronomers will do calculations a following way. Instead of like asking what's the probability of that. For example, I've been to Antarctica twice. I've been to the South Pole, which is, you would just be bored out of your mind probably, because all it is like going out into the middle of the Pacific Ocean and freezing it. There's nothing to do there. The coast of Antarctica is really cool. So this is a rock from there. They have like volcanoes there. That's not for you, but that one I got to take back because that cost me $50,000. That cost you, the taxpayer, $50,000.
Wow.
But this you can keep. This is from the South Pole's gift shop, Joe. That's a patch from the United States. We have such cool freaking scientists, man. Our country and the world. I heard something. I was like, I wonder if Joe knows this. It's totally random, but just like, how cool is freaking science?
It's pretty cool.
Do you know they can measure? And I'll get back to your question in just a second. They measure like the stress levels of whales, and they can use the stress of whales to determine if like the Soviets or the Russians are testing bombs under the ocean floor. Like, what the hell? I heard this talk recently. A woman studying whale earwax. So whales don't have ears like ours that stick out. I know it would not be good for like swimming around, right? There's a lot of friction. But they have like these vestigial things because they like evolved from wolves. Like I always thought like stuff came out of the water and that whales evolved into wolves. No, they think that wolves turned into whales.
Really?
Yes.
Wolves?
Yes. I don't know. This, Jamie Hatzfeld,
Whoa.
because I am a total ignoramus, but this is the going theory, that whales
God.
evolved from wolves. So like most mammals, they have ears. Those ears have been covered over. And what happens to a whale is that it retains earwax. And there's earwax in the whale. The whale doesn't hear with its ears. It hears through its jawbone. And that reverberates, and that's how it senses sound. But it still has vestigial earwax. They sample the earwax of dead whales, and they can measure how much cortisol, the stress hormone, is in the whale. And they know the migratory patterns of the whale. Science is, and they do some of this research in Antarctica. So anyway,
That's really fascinating. But we're kind of getting off topic.
I know,
I
we're
want
definitely
to
getting off
understand how you can look at all of the variables that are possible in terms of the composition of planets, in terms of temperature, in terms of also different kinds of environments for life that we haven't encountered yet but could be real, different kinds of life, things that are very, very alien to what we perceive of as carbon-based life forms. I just don't understand how you're looking at one planet that has a very different environment than Earth, even though Earth has life and it doesn't, and using that one example to sort of dismiss the possibility that in the insanely vast universe that there couldn't be something that's very similar to the conditions of Earth.
yeah, no,
That
100% right. You're 100% right. And I'm not saying that. I'm not saying I'm ruling it out. I'm saying there's what's called evidence, prior information.
Right.
And you should be able to say that how likely it is, you should be able to run a simulation, say for every time there's a planet that's rotten with life like the Earth, there's some odds in the overlapping communal history of those two planets in a binary planet system that they should share life. And then you get a number. I'm not saying I know that number, but you should be using that as information to sort of say what is the fecundity? How likely is it for life to get started? And once it starts going, I believe evolution can take over. But you just keep kind of kept this notion that because the universe is so vast. But the reason I brought up Antarctica and these whales, and I know it sounds totally irrelevant, but I've been there twice. Okay, there's 4 different animals that I've seen in Antarctica. Okay, and there are these giant seagulls called skuas that will frickin' rip your face off if you leave it out. They're just nasty birds. Okay, there's penguins, and on the continent itself, and there's seals, and then there's people. Okay, so this is 1/7 of the continents of Earth. There's almost no other life on Earth. But imagine you could make the same argument. The Earth is so big, and like wherever there's a continent, there should be life. But you don't see cities in Antarctica. You don't see not even like other people. You don't see like, well, there's still Neanderthals down there. There were dinosaurs there at one point, but I'm saying right now. So just by saying that there's the large number hypothesis, is that there's so much possibility that leads to probability. That's a logical fallacy. Just because there's a large number, there's a potential.
Right. If Earth didn't exist. But Earth does exist, and humans do exist, and Earth is rich with life forms. We know that it's possible.
That's true.
And we know that it's possible given the parameters that Earth enjoys.
That's why I say.
We know that there's an insane amount of planets out there that could replicate this environment.
Right. So wouldn't you then say, again, if you knew that life is so incredible, there's these extremophiles that live in volcanic vents 3,000 meters under the ocean. So again, you have to say, like, what are the odds that we would not see life on Mars or on Enceladus? And I'm not saying there is no
but it's
life.
just Mars. It's one example. And it could be that life requires a very narrow window that we enjoy.
Sure, that may be. But look at all the other factors that go into life existence on Earth. We talked about Jupiter before. There are scientists that believe that without Jupiter, we wouldn't be here because Jupiter is like a big vacuum cleaner.
Right.
There are scientists that believe that if the moon wasn't as close as it is, that the moon is exactly the same angular diameter as the sun from the Earth. Do you know what that implies for you? And next April 8th, when I come and visit you again, there's a total eclipse of the sun.
Oh, wow.
So I'm going to take you, if you're willing, I'm going to take you to show you the eclipse.
That sounds like a lot of fun.
It'll change your life.
Where would we
go? We're going to go up to San Antonio.
Oh, nice.
We're going to drive. It's easy.
Okay.
Or we'll fly. We'll get
It's only a 90-minute drive. It's not even 90 minutes, right?
Have you ever experienced a total solar eclipse?
I didn't experience it because I remember, was it Donald Trump that was staring at the sun? Wasn't it? It was him?
Yeah, it was.
It was him. And I was like, I'm not going to be that guy. I think I did try to look at it. Yeah, now that I remember.
But it didn't come through here. So anyway.
No, it was in California.
If you were to see it, you would the experience that you had on Mauna Kea will seem like, like you're just going down to the bar or something.
Really?
This has changed your life.
Okay, I'm in.
This will change your life.
Damn it, we told everybody we're going to San Antonio on April 8th. It's going to be a real problem.
Well, we'll find a secret place.
A lot of freaks.
Yeah, exactly.
Freaks are going to show up.
Okay. But the reason I bring that up is because it happens to have the exact. Have you ever seen the far side? There's no dark side of the moon. There's a far side of the moon. Right? It's riddled with craters. Guess what? Each one of those is a target. Is a Secret Service agent that took the bullet for us. Okay.
Right.
Any one of those could have exterminated.
Yes.
The fact that we did have a huge impact 65 million years ago that led to the advent of the mammals to replace the dinosaurs. The fact that we have internal terrestrial magnetism that then allows cosmic radiation to avoid impacting the Earth where the population is the largest of all species. The auroras are in the north; they're not in the equator. We don't see them here. The existence of plate tectonics, which is lubricated. The going theory about plate tectonics, I don't know if you've heard this, but that it's actually a lubricant. You ever heard of like dry graphite is a lubricant that like you put in guns or whatever? But that the continental shelf is moving over these things. They think that that's a precursor, a requisite for life. Okay, let's do the following very simple calculation. Imagine there's 8 things. You're God. You say, to have an iPhone, you're going to need 8 things. I think there's like trillions and trillions of things. But imagine there's 8 of them, okay? And imagine each one, that the Earth has a moon that's just the right distance to have tides to slosh biological material back and forth from the earlier. And that has plate tectonics, that's 2. It has a Jupiter nearby. It eventually gets hit by a Chicxulub meteor that kills off the big dinosaurs. It has a diurnal period that's compatible. It has a magnetic. Okay, let's just say there's 8 of them.
Right.
Let's say each one has a probability in your godlike cosmic roulette wheel of 1 in 1,000 for each one of those 8 things to occur. 1 over 1,000. Now, if you take that, and I think it's 0, it's like 1 over 10 trillion for some of these things, right? Now, take each one of those. So take 1 over 1,000, raise it to the 8th power. You get 10 to the 24th. Guess what that number is?
What?
It's the same as the number of stars in the whole universe throughout history. So in other words, one thing, only 8 different things that had to occur to make life in my simplified God computer that Joe Rogan is controlling. And the probability of those 8 things only is only 1 part in 10 to the 24th. Then the problem is you're multiplying a large number by a number that's completely unknown. The probability that all these events could line up to make life. And you're saying anything times infinity is finite.
Right.
And I don't
but can
agree
I
with
stop
that.
you? Is that? But we're not necessarily saying that. For first of all, is it conceivable that there would be solar systems that don't have the sort of asteroid and meteor activity that we do?
Of course, yeah.
So wouldn't they maybe not get as pelted by asteroids and meteors and have more time to develop? Isn't that conceivable that there could be a different kind of life? If we find so much variety of life, like we talked about the volcanic vents, and isn't it possible that there could be other ways that life could form in different environments that may be hostile to biological life on Earth, but not to whatever evolves there? When we're talking about an infinite number of variables, when we're talking about so many different planets.
But why is it that the large number? See, again, that's the Carl Sagan. If there's no life in the universe, it's a big awful waste of space. But that implies
I don't think that's true. I think that's
what he said.
I believe that he said that.
Yeah.
I'm not saying
Yeah.
that he didn't say that, but I don't think that way at all. I think we're so silly to think that this finite thing that we call biological life is the most significant thing and something that we know is at least 13 whatever billion years old. That's so insane that human life, which is just like this never-ending cycle of birth and death with this one particular organism, that thing is the most important thing that's going on in the fucking universe. That's so crazy. As much as I love people,
I know, but you
that
don't
is
have
such
any
a-
evidence for that, right? I mean,
What do you mean, evidence for what?
you can't say that we are not alone, right?
You can't say we're not alone. But, I mean, it's just the idea that that's the most important thing, that biological life is the most important thing.
I mean, I'm coming from a religious perspective, right? So I'm going to say that we believe that humans have infinite worth and that we're made in the image of God, right? That we have godlike abilities. So how many other godlike things could there be in the universe? Maybe, and again, I don't want this said that Brian Keating, astrophysicist, believes that there's definitely no life. I believe that there could be life. In fact, I believe that there is life outside of the Earth, but I think it came from the Earth.
Interesting.
Through
like
panspermia. Exactly.
Yeah, interesting. You mean in the whole universe itself that it's come from the Earth? That
Well,
Earth is
even the most, and I think you had Adam Frank, professor at University of Rochester, on about 5 or 10 years ago. He does the following calculation. He basically proves that it's likely that we're not the only technological civilization in the universe over the universe's history. And I love Adam. I'm like, who gives a, you know what? You know what he's saying, Joe?
Who gives a everybody?
No.
don't
Listen,
they?
Joe.
No?
Listen
Okay,
to what he says.
I'm listening.
He said that that there was at least one civilization, with a probability greater than 0, out of the 10 to the 24th power, a trillion planets and stars in the universe, that there's been one civilization throughout 13.8 billion years. That doesn't mean in our solar system. It doesn't mean in our galaxy. It doesn't mean in Andromeda, the Small Magellanic Clouds. It doesn't even mean right now. It could be that life could have formed 100 million years after the Big Bang and is gone. So is it relevant to you? Like, it's unknowable. I'm saying what he's saying is at best it's unknowable because we can't contact the species that's extinct.
Right.
We'll never travel to a place that's beyond a few light years from Earth. And so then you can say, of course, well, why don't we think that there are more laws of physics than we even know about? Of course, if we lived 100 years ago, we'd think there are 2 laws of physics, right? So I don't want to be arrogant. I don't want to say I know for sure. That's why I will never say that. But I'm saying right now, if you had a bet and there's some kind, you would make that bet, yes, there is life. And maybe you even bet there's technological life because maybe you believe that there's, that there are extraterrestrial beings that are visiting us, or perhaps there could be the possibility. You would say yes. I would say no. And I would say, based on what evidence can you say that there's life outside of the Earth? I'd say right now there's 0 evidence. You would have to admit that, right? There's no evidence.
There's no evidence. But a lack of evidence is not evidence that it doesn't exist.
That's absolutely true.
So when you are seeing all this UAP disclosure talk and all this stuff, what is your take on this stuff?
So I've talked to people, Ryan Graves, who you've had on. I've talked to. I actually did a podcast with his wingman, one of his former Navy pilot wingmen.
I listened to it.
Yeah. Oh, good. Thanks.
It's very good.
Yeah, I shouldn't have
Great
said thanks
discussion.
before you said it was good.
It was, it was very good.
Thank
It was
you.
very, very interesting.
I appreciate. I'll put that on my resume. So we talked and remember earlier, like 2 hours ago, I was going to ask you for advice, and I'm such a blabbermouth. I didn't get to ask you for advice as a podcaster.
Yes.
The advice I want to ask you is when you're talking to somebody, and for one reason or another, maybe it's your past history, maybe it's research that you've done independently that even an expert hasn't done, and you're thinking this person's wrong, or
Yeah.
this person's making a mistake. Has that ever happened to you? And if so, how do you deal with that as a podcaster?
It's complicated. I mean, I always do or try to do my very best to let someone express himself fully before I interject. But there are some times where you have to say that's not true.
Mm-hmm.
That this is not what you're saying has been disproven, and this is like we should show how it's been disproven. Or you could be talking about something that I'm an expert in.
Mm-hmm.
Like if someone wants to like from UFC, for example,
Yeah,
if somebody wants to say if you wanted to fight in the UFC, all you need to do is learn kung fu. If someone said that, and I'd be like, you're out of your mind.
Or it's as fake as
Like,
wrestling, right?
yeah.
You could say you're totally full.
Well, that's someone that's delusional. But I mean, anybody who watches the fights, they know they're real. But if someone had like this very distorted perspective on something that I know a lot about, yeah, maybe I would be like, that you shouldn't say that because this is why that's not accurate.
So I'm talking to Ryan Graves, and I've talked to Lieutenant Ann Dietrich, who is the wing woman, I guess you'd say, of Commander David Fravor, who you've had on. I've talked to them, and I've talked to them. Okay, look, I'm a pilot. I fly little Cessnas around. It's not going to be like, I'm talking to Super Hornet pilots. I'm like a schmuck, right? But, when you see things like, I'm told, like, I can't question them because I didn't serve in the military, or they have great hand-eye coordination, or they're trained observers. I actually know. My flight instructor told me a couple of things. He said to me, you relying on hand-eye coordination, are you relying on your innate abilities as a pilot, or your ability to perceive things is going to get you killed? And he wasn't like some military pilot. I don't know, my stepfather was, but the point being, you're trained to ignore your senses and pay attention to your instruments. Therefore, the human factor is irrelevant. Like the fact that he can land on an F-18 on a carrier at night in the middle of a typhoon doesn't have anything to do with the fact that like he is not necessarily better at judging evidence versus me as a scientist or even as a layperson. Okay. So we're talking, and then I hear things like, well, he witnessed this, or he saw this, or he has data about this. And by the way, he's been to my house. I've had him for Shabbat dinner, and I like Ryan a lot, and I like Ann Dietrich, and Fravor sounds really great. When you hear them say things, and then they will say things like you and Eric talked about, okay? They're defying the laws of physics, or these things cannot occur within what we understand about physics.
Right.
They're not physicists, and I'm not a pilot, okay? But we can use our various skills. When I see things like, he saw this. No, he didn't see it. He didn't claim to see it. And even in your
Ryan
interview,
Graves did.
Ryan Graves did not see anything
No.
with his eyes. He saw things on radar with a system that was newly upgraded in the Super Hornet Mark D that he was flying, okay? Recently upgraded.
Yeah.
Doesn't mean it didn't happen. Fravor and Dietrich, when they were flying, they saw things and they tried to perceive them from great altitude, something the size of a school bus, and how fast it was moving relative to the ground. Okay, then there's data. Then there's things from the Princeton. So I've looked into these things. I know the limitations. I know an awful lot about radio technology, radar sensing. So I don't think that being a military pilot, as much as I don't have the balls to do what any of them do, and I never had the guts to sign up to the military, though I might have liked to, doesn't mean that we accept what they say uncritically. And in Ryan's case, I find it unpersuasive. I don't mean to say that it's not important. It's very important. It's very significant what he's doing. Because I think at worst, it could save the lives of pilots. If it's some Chinese spy balloon, it could be American PSYOP. It could be doing all sorts of things. Or Grush. I don't know if you've talked to him. I haven't talked to him. Claiming non-human biologics, which is like non-cow animal. Okay, what is that? What does that mean? Is a slime mold? My favorite thing.
What did you think of the Fravor video evidence?
So this is the Tic Tac or the yeah. So. This is going back to 2004. And by the way, all these things occur in military, preponderance of them occur in military areas.
Very important point.
what's happening with Ryan, and I've flown through that area. You can fly through it. If I take you up my little Cessna, I will fly you through this warning area. It's not some like secret thing where Area 51 is they're blowing up stuff or nuking alien artifacts.
Is there restricted airspace out there though that you're not?
It's
allowed
a
to
warning
travel in?
area, which means that if you go into it, you could be intercepted, but for fun, and not for fun, for training. So what an F-18 will do?
Oh Jesus Christ! They're gonna practice on you. Oh my God!
That's how they train their radar systems.
Oh my God! They're gonna practice on you if you fly your little fucking propeller plane. Do you know how horrifying that would be? If those Jews just buzzed up on you in a fighter
Guys are
jet.
serious killers.
Oh my God! And those things are so fucking fast.
They're fast.
I flew with the Blue Angels once.
You did?
Yeah, it was
No,
amazing.
that's awesome.
It was amazing.
Did you puke?
Yeah, I did. I did puke.
I
I
know.
did puke, and I was so embarrassed because I'd gotten through 7.5 Gs, and I made it. From hooking. The thing you do where you
Yeah.
hook. You're forcing blood into your brain, and I did that at 7.5 Gs, and then I failed to do it on a lesser turn, and I blacked out.
You blacked out.
Yeah,
Tito Ortiz.
I just fucked up.
It was,
No, it wasn't like his was crazy.
Yeah, it was great.
He was in
like
one of those
centrifuges,
yeah,
yeah.
that thing's insane. What I did was I could have survived that one easier. It was not as bad, but I didn't do it in time.
Yeah.
And it was like it came upon me so quick, and then when I came out of it, I threw up.
This guy Hazard Lee he's got a good.
It's wild
yeah.
because it's like an elevator door. You
Tunnel.
see the black closing on the sides, like literally like an elevator door, and it's almost like you're forcing the door open, like hoot, hoot, hoot. When you're doing that, you're forcing that blood into your head, and it keeps you conscious.
Have you ever been knocked out?
No, never been unconscious.
That's wild.
Yeah.
I haven't either, thankfully. But my
Everybody
kids are getting
can
bigger.
be. Everybody
Yeah.
can be. I just
Everybody
haven't been
can.
hit the right way by the right person.
That's right. Thank
But
God.
God,
We
I've
need
seen a
you,
lot
Joe.
of them.
Yeah.
But the point is that like that, if you're dealing with like that kind of speed is fucking insane.
Oh yeah.
But the thing that they're describing, that Ryan Graves is describing, is something that's able to stay stationary at 120 knots of wind. The thing that the Commander Fravor and what their radar detected was that this thing had gone from 50,000 feet to 50 feet in a second.
Okay. So
So
what would happen if that happened? You're actually holding right over there. What would happen if that happened? You had any kind of material
Right.
traveling through the Earth's atmosphere
Right.
at such a speed would be at least illuminated and at least probably be incinerated. But okay, so then the argument becomes, well, maybe they have advanced metamaterials that we don't have access to. Okay, so you can keep adding things onto it, which is
Yes.
exactly, by the way, what this guy Gupta and the galaxy thing did. He keeps adding, if you keep adding parameters to your theory in order to make it fit observations that otherwise don't comply.
Yeah, but observations backed by data. And this data is from these very advanced military detection systems that did detect this physical object that was witnessed by 2 fighter jets. Isn't another possibility that there's some method of propulsion that it's not propulsion at all. Instead, it's manipulating gravity, manipulating whatever the fuck it's doing to go from one point in space to another point in space almost instantaneously. But not biological, not like a physical thing inside of it. I'm talking about like a drone.
Okay, so the reason you've heard, or I mentioned this Chicxulub, which is the meteor crater
Yes.
off the Yucatan Peninsula, that was the theory in which that was kind of unveiled was a physicist, nuclear physicist, Nobel Prize winner named Luis Alvarez, who plays a small role in Oppenheimer, that you'll see. And that he was responsible for radar in the World War II as part of one of his jobs. And he realized something that they could do. So radar works by interrogating an object with radio frequency waves that travel at the speed of light and bounce off an object, and you can get timing between when they get bounced off and when it comes back, and you can measure the distance to them, and you can measure the speed if you get a couple of those measurements. That's how radar works, and it's totally similar in concept to what you described with the advanced military instrument. Luis Alvarez was a creative, incredibly brilliant scientist. When he was working on that plan, he knew that the Germans and the Japanese could have similar technology. And in fact, they were starting to develop it. It turns out the Allies were good at not only the Manhattan Project, but they were good at developing radar, and both were the technologies that were crucial. But the Germans were developing it too. He realized that there's something called the inverse square law, which is that the signal gets weaker, not as the distance away from it, but it gets diminished by the distance to the second power, meaning that if, as you go away from something, the gravitational force that you feel if I double the distance is 4 times lower. That's Newton's law of gravity. The gravity force decreases as inverse square. It also holds for radar reflections. So Alvarez said, I could spoof the Germans by intentionally, when they send me a signal, I'm going to send them a signal when I'm coming closer to them. I'm going to take their signal, I'm going to diminish it, I'm going to shoot it back exactly as the inverse square, because he knew how far away they were too. So he spoofed them. And he transmitted the signal. So even though he was getting closer, they thought, oh, nothing to worry about. He's getting farther away. And then the planes would blow up the radar sites, and then they'd be blind. Okay, and now that's just one example. Now, what would the German radar operator have said? That object defied the laws of physics. It was getting closer, but my radar showed it getting farther away. I'm not saying that's what happened, Joe, but haven't I provoked a little bit of a doubt that maybe there could be other explanations other than alien technology? In other words, you combine...
I don't necessarily think it's alien.
What do you think it is? Psyop.
I think I think there's a real issue with it being in these areas of heavy military activity. And I don't think it's outside the realm of possibility that the United States has developed some black ops secret project where they've figured out a way to do something with drones that's unprecedented.
Right.
That I think.
But why is it
when they're talking about it openly, as soon as they start talking about it openly, crafts out of this world, I smell bullshit. Like I've said it multiple times on the show. There's something about this that doesn't feel real. And I also gave myself the possibility that maybe if disclosure did happen, it would be so preposterous and so strange and alien just in the idea that there's life outside this planet and that it's more advanced than us and that it's been visiting us forever. Maybe that would feel so fake because it's so crazy that it's almost impossible. There would be no context other than fiction movies. Yeah. So like I wouldn't be able to fit it in anywhere, and it would seem fake. But that's not what I'm getting out of this. When I'm watching all this, I'm like, man, I feel like someone's lying to me. I feel like I'm being duped.
You know what?
And I don't know why.
You know what really spoke to me, and I felt sorry because, again, I haven't met Fravor, and he seems like a patriot, and again, he's got more bigger balls than I do. When he got back to the carrier, do you know what they kept doing?
Yeah, they're fucking with him, saying he saw UFOs. But a lot of those guys had seen them, and they not just seen them like one time. They'd seen many of them. And I just have this idea that if they were going to do something with some really advanced shit, wouldn't they do it in restricted airspace where the fucking military operates all the time? Of course, they would, like, is it weird that it's happening off the coast of Virginia and also off the coast of San Diego where there's massive
areas? Yeah,
I mean, this is like... It seems to me that that's more likely. But then again, there's these instances of people encountering these things. And the concept of interdimensional travel, whatever that means, whatever interdimensional travel. I know Grush tried to sort of explain that in some sort of a strange way. Yeah. And physicists pulled it apart and said, doesn't make sense. That's not how it works. But the concept of exposing other... Like, wasn't there some... What was this? Let me find. There's something I saved that I wanted to bring up with you. There's some. God, was it like a new? I'll find it.
Okay.
But the point being that there was some new discovery that could lead to the possibility of travel to other dimensions, or at least detecting other dimensions in a method where you could conceivably prove that there is something else outside of what we're physically capable of experiencing.
Yeah, no, you're absolutely right.
And
in
that
fact,
beings could come from there.
Okay,
that's where it gets, that's next level.
That's a wormhole too far.
Yeah.
But it is true. In fact, when I said the inverse square law, that is a very, very accurate way.
I want to find that now.
Yeah, sure. I'll just talk about this. But
Please do.
In a higher dimensional space than 3 spatial dimensions plus 1 time dimension that we enjoy,
I found it.
The light or gravity would decrease with an exponent greater than 2. And so these black holes that crash together and release gravitational wave energy, again, my friend David Spergel, they've been able to set limits on the dimensionality of space-time, and it's very, very close to 3 dimensions of space, and from an object that's 1 billion light years away, Joe. So yes, beyond that, anything goes. And but go ahead with your.
I sent it
research.
to Jamie. This is the thing. It's definitely not my research. New fucking pop-ups. New force of nature. Scientists close in on a fifth force.
Oh, yeah.
So what is this? They discover mysterious subatomic particles disobeying the laws of physics.
I just want to look at your face when you get incredibly let down. Okay, here we go.
Yes, let me down.
So when we talk about forces of nature, so there are four main forces of nature: gravity that we're familiar with, right? And then there's the electric force, and then there's the magnetic force, and then there's two types of nuclear force. One is called the weak nuclear force, that's like radioactive decay, and then there's a strong nuclear force that's responsible for things like fusion and so forth. When we look at these particles, we say for each type of force, there's a corresponding object that responds to that force. Say it could be mass, like matter, like we're made up of, and there's a boson, and the boson communicates the force to that massive object. So the Higgs boson is what gives particles mass, and that's the mechanism by which we acquire mass and inertia, resistance to motion. Electricity and magnetism, they're communicated by a boson called the photon. The photon is the gauge carrying force that propagates the interaction between magnetic fields, electric fields, charges. And then there's strong and weak nuclear forces. We don't have to get into those. This is saying that there seems to be a new calculation, a new data that's been discovered in what are called muons. And these muons have a relationship between their charge and their spin. And that charge-spin relationship, for one reason or another, should be exactly in a ratio of 2. So their spin versus their magnetic type of property to their spin. And so this little dreidel, one of your last pieces of gifts here. So there it goes there. Not a dreidel. It's a top. See how long you can get that to spin for. Okay, so what they're showing is that, so see that thing is not only spinning on its axis, but the axis is moving around, Joe?
Yes.
That's called precession. That precession for a muon, you can think of as a little tiny spinning top also, and that will have a special relationship between its magnetic properties as it's spinning to its physical angular momentum, which is what this thing is doing.
It's like the precession of the equinoxes.
Exactly wrong. No, it's yes, I think you're right. Yeah.
Still going.
No, it's true. Yeah. Okay, and now I'm going to do something else for you. Okay, so you got that to spin for like, I will give you $100,000 if you can get this thing to spin in both directions over 20 times.
This thing?
This thing. That's all I want you to do. So
What is
each
this?
direction.
What is this thing?
It doesn't matter what it is, Joe. I found it in a crashed UFO.
20 times. No.
No, that didn't count. You can keep trying. I'll give you as many tries as you want. Okay, that's 1, 2, 3, 4, 5, 6, 7. Now do the other way. Try it again.
What's the best way to do it?
I'm not going to tell you. I'm not going to give you $100,000.
I'm just trying to.
I don't have Spotify money. That was the original way you did it. Now do it the other way.
Okay.
Do it counterclockwise.
I'm getting better at it.
Can't do it.
Why is that?
Look at it. Is it symmetrical? Isn't that cool? That's just a simple. There's nothing crazy about it. It's called a rattleback. That thing has symmetry about more than one axis, and such that when you spin it in the direction clockwise, it'll spin forever, like the dreidel. But if you try to spin it the other way, it stops and goes back because there's torque
But
being.
that is the other way.
Wait,
That's counterclockwise.
that's the first way. Now do it the
That's
other way.
counterclockwise.
Well, okay, stop.
I think
Do it the other way. See?
Interesting.
Yeah, isn't that cool? But to the ordinary eye, if
Yeah,
I
it
just showed you
stops
this,
and starts going in the
stops
other
and goes the
direction.
other direction.
Yeah.
So muons will have this property that they don't have this exact relationship that's predicted by theory. Again, this is what scientists do. They have a model for how nature should behave. We make observations. Now those observations disagree at a very significant level, such that the odds of it occurring by fluke chance is about 1 in 30 million or something like that. And so now they're saying the one way to explain it is if there's another type of boson, which would mean another type of force, which would be the fifth force for those keeping score at home. So that's all that means. It doesn't mean that there's like a wormhole and that they're communicating through it. There are theories like that, but not for the muon experiment.
Okay. What do you could bring it back to the UAP thing? What do you think is going on?
Well, the Occam's razor approach is to think about it as, maybe it's a variety of sources. First of all, Grush, where is he from? What is his branch? Grush, sorry. What is he? And I'd love to talk to him. He seems like an interesting, patriotic guy.
Well, he doesn't have physical experience with anything.
He doesn't even have direct eyewitness.
Right, that's what I'm saying.
Okay.
He wasn't, but he's not claiming he does.
Right.
What he's claiming is that he uncovered these programs that he thinks, as a patriotic American, and as a citizen of the world, that people should know that there's crash retrieval programs and that they are in possession of biological entities that they keep in freezers.
Again, I don't want to condemn him. I don't want to have any smattering of an ad hominem attack. But I'll say one thing, and just you tell me if I'm being an a-hole, okay? He was given the opportunity on perhaps the greatest stage he'll ever have to name names and to say different things, and he didn't name them. And I've heard things from like Lou Elizondo indirectly. My friend Kurt Jamungal has talked to him many times, but I've never talked to him. Mm-hmm. But they'll say things like, I can't do that. It'll ruin my life. And look, Joe, I'm a coward compared to both of these gentlemen, right? But at a certain level, in front of senators, congressmen, women, to say like, I can't disclose that, but you're a whistleblower. Like you're blowing a whistle. You have protection.
Right,
we will protect you. We will defend the frick out of you.
But he's not done. What he's trying to do is get permission to discuss more things. So he has permission to say what he said so far. This is according to him.
Right.
He is attempting to get permission to discuss more. These are the things that he could have discussed with them in the skiff. That's why he brought it up this way. He's trying to do this all by the book. And it appears that there's both resistance and support for this.
Well, this is the argument I had with Avi Loeb when he came on my show. He talked about this object Oumuamua, which is this interstellar object that he claims is either a junk debris or maybe it's a tourist scout or a spy drone.
It's much more reflective, rather, right?
It has properties that can't be explained by the typical astronomical, pedantic ways of explaining things. And I told him when he came on my podcast, and I love Avi. I mean, I've had him on many times. I said, Avi, you happen to also be friendly, because I said, why don't you go after this thing and go track it down? Oh, no, he said. In a couple of years, one of the most ambitious and important observatories is coming online, and I'm happy to recommend people that work on it to you when it comes out, called the Vera Rubin Observatory in Chile, not too far from where our Simons Observatory is. And that observatory, he said, is going to capture thousands of these things, if I'm right. And I said, Avi, what if you're wrong? What if this is one-time only event? I said, Avi, I live in San Diego. And San Diego has the following properties. It's the absolute best and easiest place to be a meteorologist on the planet, except for yesterday. A freaking hurricane and a tornado and an earthquake. But it's the absolute worst place to be a sportscaster because we, of all the major cities in the United States, we have never won a world championship in any sport. Okay, so it's horrible. So last year, then the Padres got into the division series, and I'm a huge Padres fan. I should not have said, well, the Padres are in the division series, even though it's the first time, since Tony Gwynn was playing, and they've been around for 55 years. I'll just wait till next year. No. I tried to get tickets. I scalped. I couldn't get tickets. Because you don't know if your calculations are correct, but if you believe in what you're saying, track this thing down. And by the way, Avi, you happen to know a guy named Yuri Milner who's already paying your team and funding you, not personally. He's funding a team called the Breakthrough Starshot. Have you heard about this?
No.
They're going to send billions of little cell phone cameras to Proxima Centauri B. You're not supposed to laugh.
That sounds insane.
You're not supposed to laugh. But anyway, they're spending $100 million on it. And they're going to shoot these things there, and they'll get there in 20 years, and they'll transmit at the speed of light. It'll take another 4 years to get back to the Earth because it's 4 light years away. Instead of having him spend $100 million on that, why don't you get him to, get a little CubeSat and shoot it off and go catch up to Oumuamua while it's still in your freaking neighborhood?
So that's totally possible to do?
Totally possible. It's not
So
impossible.
you think he's resisting that because it doesn't... Like he doesn't want it to be disproven because he's getting a lot of attention off of this idea that this interstellar object is something from an alien civilization.
I think that's too venal. I don't think he's doing it for attention. I just think he's too in love with his numbers. He's too in love with his calculation.
Too in love with the idea of it.
But there's so many of them.
But there has to be a temptation to getting recognition, because I had never heard of him until a few years ago, and now I hear about him constantly. He's in all these interviews, and this is not disparaging.
No, I know.
It's just that there's an impulse that people have to continue to do something that gets them a lot of recognition.
Oh, sure. I mean, this is the number one.
If it's possible to go take a look at that thing, how much would it cost to go take a look at that thing?
It would probably cost less than $1 billion, say. And this guy that he's friends with is, and far be it for me to tell a billionaire how to spend his or her money, but I'm just
I
saying.
don't think you're going to talk Elon Musk into going looking at it.
Right. Well, Elon's another cat. So I know you've talked. So you have this piece of Mars, right? So he's trying to get to Mars now, right? He wants to die on Mars, and hopefully, God willing, it won't be on impact. Okay, that would be horrible if he dies on impact.
Yeah.
But Joe, have you ever thought like, which one of his 10 kids? I mean, Kanai Nahara, he's got 10 kids. Who's he gonna leave behind? Like who? Like to do
if
that.
he goes to Mars?
I think he's like he wants to go to Mars. He
Well,
said he wants to die on Mars.
By the time he is able to do this, they'll probably be fully grown adults. Maybe they can go visit him.
They go come with him.
Apparently, the idea is to be able to come back. Just like, okay. I saw The Martian. Did you like that?
Yeah, I love the Mars. Andy Weir is a UCSD. He didn't graduate from UCSD, but he wrote it. But yeah,
But, I mean, it is possible that one day we will have the technology to colonize other planets, right?
do we have the reason to do it, Joe?
What is the reason? Like,
This is what
isn't sometimes the reason just to be able to do it, or maybe to ensure that the human race survives if there's some sort of a natural disaster on Earth?
Do you know what Nixon wrote on the plaque that went to the moon on Apollo 11?
No, what?
It said, "We came in peace for all mankind." That's bullshit, right? It was a war against the Soviets. It was part of the Cold War. It was a war of propaganda, and it was important. It did a lot for science. Guess what? We haven't been back to the moon in 50 years, right? So if it was so important for peace and for technology, why haven't we been back, okay? So to say what we did, it's the Edmund Hillary thing, climb Everest because it's there, right?
Mm-hmm.
But Elon has said the following. He has said, I want to go to Mars so that humankind becomes interplanetary. Then you ask, I love to keep asking why questions, right?
Right.
Because they're so annoying. Like your kids keep asking you why. You know what the ultimate answer is. Because I freaking said so, go to sleep, right? So with him, I would keep asking why. Why do you want to send people to Mars? Why should humankind be interplanetary? So that the flame of consciousness never gets extinguished. Why? Why can't you go under the ocean? Why can't you build bubble cities? Why can't you build floating cloud
Well,
cities?
if the Earth gets destroyed,
Okay, but why?
why what?
Why
Why continue with humanity?
Not just humans, and he's talking about human consciousness, which could also mean like AI stuff or whatever. Like, but here's my bigger point. You had Ryan Holiday on recently. He's got these memento mori coins, right? Memento mori means remember you're going to die. Allegedly, Roman emperors would have some courtesan walking next to them so they wouldn't have too much hubris. They would say, remember, you're mortal, you're going to die. That was done to motivate them to suck the marrow out of life while you're alive, right? So my question at some level is, well, is that true only of individuals? Or like, could it be true of a civilization as a whole? Could it be true that like, hey, wait, we shouldn't be dedicating all this effort, and I think it's I wouldn't say it's as unlikely as life, having iPhones on Proxima Centauri b, but I'd say it's pretty unlikely that we're going to do that in the next 100 years to have colonized Mars. It's incredibly difficult from a technological standpoint, from a biological standpoint, a psychological standpoint, the raw material. There's a tremendous number of reasons that it's
But
not
if
possible.
technology progresses the way it has since 1800, the way it's the world's unrecognizable. You could conceivably say that if it continues in the same direction and we don't blow ourselves up, we may very well have the ability to do something like that.
So there's
And if you say why,
Yeah.
well, why not?
well, why
Like,
not is always a
because
good
it's
answer.
fascinating,
Right.
because it's interesting, because people want to do it, because it would be significant to have human life living on a terraformed Mars.
Put it on our resume.
Maybe we could use Mars as like a test to like how to recharge an atmosphere if we fuck it up.
Right, but isn't it better just not to fuck it up?
Yeah, it is better not to fuck it up, but it's also interesting. Like why go to the moon? Why send
sure.
satellites up there? Why look at stars?
It's part of
why
the
all
human-
those things? It's part of this human desire to constantly innovate and move
Absolutely.
forward.
But I question the Moore's law kind of compatibility. And actually, you talked about this with Michio Kaku, and he was in his new book about quantum supremacy. Which is this kind of faith in these exponential curves, and exponential curves are really tricky mofos because they sneak up on you for a long time, like and they go like this, right? Well, one of the things that they do after they do this is they do this, they come down, right? You've heard of peak oil and stuff like that,
Right.
There's only a finite amount of oil because there's only a finite amount of pre-carbonous fossil fuels, et cetera, right? But it's worse than that. As we get more and more kind of technologically capable, we get better and better at keeping the Ponzi scheme going in a sense. Like the ore grade of gold used to be like in California, 1849, right? They would stumble upon a huge brick rock of gold. That never happens anymore. That the amount of gold per ton is like a gram per ton. It's incredibly small, and it's going down. All these things are going down. They're all these diminishing S curves, they call them. They start off really high, and so you get the go-go 90, and then it drops off to zero. There's no saying that might not also happen for both extraction of resources that you need to build a colony on Mars, fuel, rocket parts, etc., but also for the coming AI and computing revolution. In other words, Moore's law is saturating for a very interesting reason. It's not that the speed of the computers is still doubling, but the amount do you care about the speed of your computer? No, you care about what I can do with it, right? How fast does the web page load up, right? Well, so you can have the fastest computer, but it's loading really slowly because there's so many other people that want to take advantage and use that same resource. It's a very highly in demand resource. Well, that will happen with quantum computing too. It's already happening with classical supercomputers. In other words, their speed is going up, but the number of floating point operations they do is saturating because so many people want to use them because they're so good. They're a victim of their own success in a certain sense. Same thing could happen with mineral. So the question is, do we get there? And if not, well, what would that mean? Would we have like a civilization existential crisis? I don't know. I really don't know.
But even all the things you just stated, isn't that just within our technological limitations as of today? And our understanding of how to put together computers, our understanding of what technology can consist of in terms of minerals, in terms of like stable materials?
Yes and no. I mean, but like I said, there's only so much carbon in the earth. There's
Right.
only so many pre-biologic fossils.
But can it be recycled? Can we find new ways to use it? Can't we figure out a way to...
Sure. Yeah, we can.
Yeah.
But the question is, these different things have to overlap. And actually, I just, because I kind of was interested to go back just to the UAP thing for 1 minute, which was... think about the human factors involved in someone like what Grush is describing. Imagine that you have this ability to go back and start with like something happened in 1947 in Roswell. We'll just say something happened. It definitely happened, right? So there were some people there that witnessed something. They might have been military. They might have been research scientists. The people had to go there, identify it, notify people. Then people had to go there and pick it up, clean it up, bring it in a flatbed truck, transport it, store it, keep it processed. Then there's biologics, right? He's saying there's biologics. So the biologics had to be processed by a biologist, not by the same corpsman who collected it. And guess what? All these guys have wives or husbands or bosses or friends and stuff. So my friend James Altucher is a very big influence in my podcasting career as well. He talks about a conspiracy number. Like, what's the maximum number of people that can possibly be part of a conspiracy before it gets out, right? Before it's exposed. Mm-hmm. And there's also overlap between that and their timescales, right? You're talking about a sustained conspiracy. If this is, let's give him the benefit of the doubt that this is true, and that's not, so. But this is now coming out now, and you tweeted about this, or you mentioned this a couple of weeks ago on a podcast. I forget with whom, but you said the atomic age coincided with the age of Roswell.
Yeah.
You mentioned that, and that's true. And there was another thing that happened during that age, the quantum age. So quantum mechanics, which is discovery of forces, fields, maybe fifth forces and unseen things, spooky action at a distance, aliens, and then the notion of atomic holocaust, et cetera, right? So all these things are in the zeitgeist at that moment. And you're right, they nucleate at that same time. What if right now is also that time? But how is it? Because now we're also talking about like UAPs, fifth forces, all these other things. And now instead of the Cold War, we have a hot war. Right? And all these things are united, and we have global climate change, right? I always say there's a concept called the von Karman line, which is the boundary between the Earth and the space. It's about 60 miles, 100 kilometers above the Earth's surface. And basically, almost everything that we're dealing with existentially happens below that line, right? Pandemics, COVID, respiratory, atmospheric transmission, a nuclear war, and the effects of such a thing on the Earth, and things in the UAP space that are happening, and the boundary between Earth and space. These are all kind of happening, and I'm wondering if it's not sort of related at some level to this kind of being in the cultural consciousness. And that's why it's all coming to date, because to think about a conspiracy of 7 decades maintained with probably a minimum of 1,000 people kept secret, there's a probability of that happening, but we should be precise about it, and we should do calculate, not dismiss it, but also be precise about it.
Well, it also depends upon what kind of people you're talking about. If you're talking about only high-level military people that have a long history of being able to keep secrets, that it's a part of the culture, and these are the only people that have access to these vehicles or this thing, I could conceivably see how someone could keep something quiet for a very long time. And then you have people that have claimed to have seen these things and worked on these things. And it's always hard when you're dealing with anecdotal evidence and people discussing things, and you don't know what's true and what's not true. What is fascinating to me is have you seen the Go Fast video?
Yeah.
Yeah. What do you think about those videos where there's no heat signature, no visible means of propulsion, and these things are whipping through the sky?
I mean, you've talked to Mick West and other people, and I'm not saying he's not a scientist in the sense that someone like I am. But some of these things are, it always comes down to like, well, whose data is it?
Right. Well, these are fighter jet pilots that are seeing these things, and they're discussing it. Play that video so you could listen to their discussion of it while they're seeing this thing. Mm-hmm. What do you think it is?
So when I look at those things, there's a couple of different things that you have to look at from an optical perspective, from a sensor perspective, from a...
Let me hear them talk.
Yeah.
So right now we're looking at this video where this thing seems to be trying to tracking it. Their systems are trying to track it, but it's... So they locked onto it now.
Did you box moving target? No, I took an auto track. Oh, okay. Oh my gosh, dude. Wow, look at it fly.
So obviously they're freaking out.
Yeah. So
they locked onto it with their weapon system.
Yeah. So there's something called scale invariance, which is where you can't really tell in certain phenomena. Fractals are like, have you ever seen like the Mandelbrot set? So no matter how much you zoom into it or zoom out of it, it looks the same. Right. And there are lots of features like that. And one of the manifestations of that is the ocean surface. There are waves on top of waves. You ever seen the beautiful Japanese woodcut where it's like wave on top?
Sure.
Incredible. So there you're seeing a lot of waves, but it's impossible to have any depth perception, right? Because we're only getting a single view of it. And there's a gyroscopic stabilization tool that they're using in the FLIR system that's measuring it, right? So there is a heat signature. That's how they can see it on FLIR, if the forward-looking infrared camera.
Propulsion.
Oh.
It's like it's universal. It's not like there's something coming out the back, like a jet engine where you could see it clearly.
So there have been mock-ups and simulations done for this where it's like you could have a balloon, you could have something spherical or something that's actually going with the wind.
But can't they detect how fast it's moving?
No. So not from that video. You can't necessarily.
But from their systems, from their weapon systems, they can't detect how fast. Like they were having a hard time locking onto it.
So I asked Ariel Kleinerman and Ryan about this, and they said it's classic. Like they wouldn't tell me what their radar is capable of saying, only that they can use it to determine certain properties of things.
But it seemed very evident in that video that they were having a hard time catching it because it was moving at a very high rate of speed.
This is 2004, I think. This video
was that one.
Yeah.
So they're trying to lock onto this thing, and it's moving too fast. And you see the crosshairs try to keep up with it, and then finally it locks onto it, and that's when they cheer that we got it, and they say, "Look at that thing go!"
Right.
Don't you think they would have an understanding of the speed that something's moving and not think of it as a balloon that's just floating around?
Well, remember, this is stabilized, so they're locking on, so they're moving in a perspective where
but don't you think their equipment has the ability to detect speed?
Do you know how big the field of view of that thing was?
I don't.
Yeah, so we don't either.
Well, I don't know if they. I don't know if they've released how large they estimate it is. So this is all leaked video, right?
Right. So if you were to look through this telescope at the moon, and there was a balloon on the telescope, floating in front of the moon, and you could see it, and it was big, and like a Chinese spy balloon or something like that, and it's moving, and you're moving, and you don't know the relative field of view compared to the size of this object. It may appear that it's going. If that thing is the size of an Embraer jetliner, yeah, that's freaking fast, right? If it's the size of a balloon being carried by the wind that you are stabilized as in a parcel of wind, it might not be.
We're assuming that there's wind. We're assuming it's being carried by the wind, but we're assuming it's being carried by the wind in the same direction. We don't know which way the wind was blowing. We don't. But what my point is that they seem to think that that was very unusual. And these aren't guys that are just like, oh my God, a balloon, shoot it.
Well, that's when I went back to the feeling of pity that, and again, he doesn't even have pity, but let's say your life, you were seeing these things, and let's just say, let's forget it. It's a Chinese war drone, military drone that's coming to blow up the Nimitz, okay, or whatever they were on, okay? And so you then, your compatriot, your comrade comes back to the deck, and you put like Independence Day posters on his rug, and you've seen it too. It doesn't. That's not what I would do. If my kid comes to me and says, I saw, the boogeyman or something, she's like really nervous. I don't say like, well, like let me tease her about it. Like, no, I remember.
Okay, I wouldn't do that to my kid, but I would definitely do that to my friends. If one of my friends said they saw an alien, 100%.
Oh, Joe, you would do it.
I would take a rubber alien, I'd put it in their bed, have it tucked in.
Okay.
Yeah, but just for fun. And that's what those guys were doing to him. You're making it seem like they like horribly insulted him. They were just busting balls.
Let me say this. Your pilot, let's say you charter a private jet sometime, okay? You're out with Lex and you're going to Vegas, right? And you charter a private jet, right? You're on the jet. The guy who's in there is flying the plane, and you found out that he actually was an ex-military pilot, and he did see one of these things. And so you get one of your friends, your buddies, dresses up as an alien, bust into the cockpit and starts, I'm the alien that you find. You wouldn't do. I mean, that seems
like a silly comparison.
I'm just
what
making
you're
the
talking
comparison.
about is a guy
their
who
life
comes
is threatened,
back.
though. But if
he
their life
comes
is
back
really
from a
threatened,
flight claiming to have seen UFOs, and his friends bust his balls.
This happened many times.
But that's in the military. That's normal military shit.
But Ryan's saying the
hanging out
opposite
together.
now. Ryan's saying no. These people are scared for their safety now. Now he's doing the Americans for Safe Aerospace. That he has to be, and part of their mission is to protect pilots.
This is
and
because of close
destigmatize
encounters with these things,
and
right?
Destigmatize.
This is the square in a circle.
The cube around a sphere.
Is it a cube around a sphere?
It's
is that
the
what
other,
it is?
it could be.
Which way is
my
it?
website.
Is it a black cube?
It's on my
in
video.
A sphere?
I made a very expensive thumbnail for my video with Ryan Graves.
A sphere in a cube.
A sphere inside a cube?
Yeah.
So this sphere inside a cube is a repeating theme, right? They see a lot of these.
On the East Coast.
On the East Coast.
Yeah, on the West
so
Coast.
do you think these things are drones? What do you think these things are?
Well, do you remember the Chinese spy balloon, that came about recently? And do you remember how we didn't shoot it down?
Yeah.
And do you remember when that came about? It was like right before this disclosure was about to get kicked off. I mean, there's some weird things that are going on. There's certainly things.
You connect those two things together, one thing that moves in a very bizarre way that they can't seem to replicate. They don't know how these things like stay stable at 120 knots. Well, according to all of his equipment, unless their equipment totally sucks. And this is like the equipment that got upgraded in 2014.
Right, but then they say, I can't tell you about the equipment. And
right, but they can tell you that when the equipment was upgraded, that's when they started detecting these things. So if the equipment is accurate and the equipment is upgraded and then they put it on these jets and these guys are detecting these things, and then there's visual confirmation of these things by multiple pilots, and it's a reoccurring thing. They see them in the same areas all the time.
Well, then why wouldn't the government go out? Why wouldn't they be sending out? I asked Ryan that. I said, why don't they send out sorties every day if they're doing it at nothing less?
Because
they could do
maybe
it for
it's
training.
theirs.
You're right. It could be.
Maybe it's theirs. The U.S. shoots down another flying object over Canada. What did they shoot down?
Yeah.
What they shoot down?
They didn't say.
This is the...
I'm sure that... Well, I had Mike Baker on, who used to be with the CIA, and he was
right.
explaining all these Chinese balloons.
Oh, this is from Eric Weinstein shared this yesterday. He said there's these three different... It's on the screen. There's a map of three different NORAD shots that happened. This is from time. And like... He just says, like, I don't remember these happening. Do you
know how much each one of those missiles cost, by the way?
No.
It's over $1 million.
Didn't they miss once?
Yep.
Haha.
Because you're not like shooting.
Where'd that fucking missile go?
These balloons that people don't realize it. When you're at altitude, it's not like this. So
Right.
like the pressure outside is almost equal to the pressure inside. So if you shoot it like with bullets and pepper it with bullet, it does nothing. It's just like opening a door in a warehouse. You have to like detach it from the payload. That's why they shot it with a missile.
Oh wow.
So those are $1 million a pop. But I wanted to just get back to the
possibility of what they are.
The possibility of what they are. So I always have to look for the simplest explanation of what they could be. And certainly the simplest simplest. I don't think anyone would disagree. The simplest explanation is certainly not. These are interdimensional beings that have traveled across the literal equivalent of trillions upon trillions of miles, or if you like, thousands of light years or millions of light years, as objects, only to navigate that whole way and end up being sighted off of Catalina Island and Newport News, or Virginia.
Maybe they don't care if they get sighted. Maybe that's part of their fun.
But yeah, right. So then there's a teleological explanation. We're trying to propose a mechanism by which that motivates some species or something to do that, right? Now, Avi, to get back and give him his credit, because I don't want to be perceived as I'm denigrating him in any way, but he has built this Galileo project. And I should say, I never got interested in any of this stuff, Joe. Although I do think if it were true, who should be the most interested in it are physics professors and physics researchers, right? Because if this is true that there are creatures that mastered the interdimensional manipulation of space-time, that would shortcut me and my colleagues 4 or 5 centuries, right? And it would be just a revolution. Think of the Nobel Prizes you could win, right? Think of tenure. You could get tenure.
If you were allowed to have access to it.
Right.
If they do have some sort of a back engineering program, who could conceivably be qualified to do that?
Well, this is where I disagree with Eric. I always say Eric, Eric is my atomic clock. They say like a broken clock's right twice a day. Like Eric's almost always right. He's in my atomic clock, so I get a great deal from Eric. But when he says that these objects that we need, we're the theoretical physicists studying this. I claim you don't really need theoretical physicists to study it yet. You might instead want experimental physicists such as myself and my colleagues, that people that are used to dealing with data, with sensors, with actually building technology, observing things. Again, observing the skies. We've been watching the skies in all wavelengths. By the way, you only see it with like visible light. How come these aren't showing up only in the radar microwave region of the spectrum, infrared? Why would they choose the narrow band of wavelengths that some marginal species of primitive apes, evolved apes have sensitivity to? Namely, this narrow window. This is infinitesimal.
You're saying why wouldn't they hide themselves?
Why wouldn't there be other modalities in which they're observed other than visible sightings, eyewitness sightings? Which, in other words, why couldn't they manipulate the signatures that they travel in? Maybe they'd be neutrinos. Maybe they could be using gravitational waves. Who knows? Mm-hmm. But that you don't need Edward Witten to help you with, right? You don't need a theoretical physicist. You need an experimental physicist, an observational astronomer who's used to looking through telescope. My whole job, Joe, is staring up at the sky with things like this in all different dimensions and looking for objects that don't seem to make sense or looking for phenomena that have never been observed before.
But why would you assume that they would want to hide?
I'm not saying they would want to hide. I'm just saying they seem to be evasive, right? So, in other words,
maybe just the way they travel is so insane that you can't really detect
They
them.
only go on Catalina Island and Newport News. In other words, how come they're not over the observatory that's in western Texas that the University of Texas
How come
operates?
they get spotted over military bases?
Well, that's what I'm saying. So does that lead you to the fact? If I just told you nothing, but they happen to appear in restricted warning areas, military areas, would you say that they're would you say that makes them more likely to be aliens? I wouldn't say that.
I wouldn't say more likely. I would say if I was an alien and I came here to observe a territorial ape with nuclear weapons, I would probably check out where the nuclear weapons are. I'd be like, what are these fucking crazy assholes up to? They're blowing themselves up by dropping bombs out of planes, and they have enough missiles pointed at each other all over the world to essentially eliminate all life.
Well, that's the opposite.
I think I would look.
Yeah.
I think that's where I would look. I think I would look over those military bases, and I think I'd maybe let myself be known.
Only in
Shot
America?
them all down. Yeah, we're the best. We're number one.
We are
the aliens
number one.
know it. I mean, there have been multiple sightings. I'm sure you know about this.
Yeah, but
There's been many.
if you look at the map of sightings,
It's far more America. It's a very American themed idea, particularly because of Roswell.
Correct. And you know that when Venus, the planet Venus, is not visible, that UFO sightings go down by over 40%.
Oh, I'm sure. You can explain away the vast majority of them. And then you can also there's people that hallucinate. There's people that they have mental health breakdowns where they actually believe that things happen that didn't really happen, and some of those things could be a UFO abduction. We know that people have wild, vivid dreams, and then we know that the border to dreams and consciousness is. Why are all these UFO abduction stories at night? Were you dreaming,
Mostly men,
Bob?
right.
Yeah, Bob, were you dreaming? Did they really touch your butt and take your sperm?
Here's an.
You know what I mean? It's like,
We've reached the limits
but
of rectal
it's
probing
not like
abilities.
they happen while you're at work. It's not like they abduct you when you go to the restroom, and and all of a sudden something hovers outside the window and pulls you through, and you know what I mean? It's
No, I
like
know what you
always
mean.
in the middle of the night.
But let me ask you this. So when I brought this up, when I first got interested in this, it was really, I should say, I have this disposition, as you've already uncovered, that I don't believe that there's extraterrestrial technology in the whole universe with high confidence, or even with moderate degree of confidence. So therefore, I certainly don't believe that there are, I'm not predisposed to believe that there are alien technology crafts visiting the Earth, right?
Right.
So, but when I talk about that and I say, look, there are these astronomers and there are these people like me who study things, and NASA, and part of the reason I got interested to take this seriously is my friend David Spergel, who's one of my mentors, and he is leading NASA's UAP investigation for NASA, which didn't report last month. And so on Twitter, this whole thing is like, well, how come you're not at the reporting thing, and we don't have any reason to trust NASA? There's a whole subculture, which I think is like almost like denialism, whatever form you want to employ for that, but that won't accept any explanation unless it's aliens. And there's a huge subculture, right?
There's
So
a
how
huge
should I, as a
subculture with that.
scientist, interact with a layperson who's educated, well-meaning perhaps, but has this deep distrust of science, scientists, the scientific method? I mean, how do
I don't think they necessarily have a deep trust of science or the
Or
scientific
NASA, or say
method, or
NASA.
even now. But I think there's a large number of people that have a vested interest in believing that aliens are amongst us and that UFOs are real and that disclosure is about to happen, partially because it's fun. It's very fun. The idea of thinking that there's aliens out there is so exciting. I love it. I mean, obviously,
Really?
there
I
are fucking
could never-
aliens everywhere. But I'm also skeptical of things that just seem fake. There's something about this whole thing that seems like a show. And it really kind of brings me back to, I mean, I'm not accusing people of mind control experiments, but it has been done in this country many, many times. And one of the big ones was MK Ultra and Operation Midnight Climax, where they set up, the CIA literally set up brothels and gave these Johns LSD and monitored them through two-way mirrors. We know that there's been psyops before.
You're right.
And when there's all this discussion about like out-of-world crafts and not of this world and we have alien bodies, I'm like, yeah, fucking stop talking. Show me some shit. At a certain point in time, you're going to have to stop talking and show me some shit. Because right now, I'm like, I don't like the way this sounds.
No.
It sounds funky.
Let's take
And,
one more
and
lap.
this is someone who thinks that aliens are real.
No, I know you do, yeah.
I just think there's something about this. Like, I believe Commander David Fravor. I believe him. I believe that he knows what he saw. I believe he saw something extraordinary. I'm just not, I don't know where it came from.
Right. So
But the idea that we had something like that in 2004 is even weirder.
yeah, you're right. No.
That's even weirder because it's like now we're talking about there's a giant difference between 19 years ago, the physics of 19 years ago, our understanding of propulsion systems, technology, computing, everything.
iPhone plethora. Yeah. We didn't have the iPhone back then.
We didn't have anything back then. We had shitty little fucking flip phones. It's just such a different world.
Well, let me run this by you. So, what the United States government did to Native Americans, tremendous atrocities, right? There were but there was almost as much done. I don't want to say almost. There was a lot of intertribal warfare where we would cause them to fight with each other.
Yeah.
And that was part of our strategy to atomize them and to reduce their capability to mount some kind of a force against the United States government, which is truly awful part of our history. But nevertheless, they, so that there was also a plausible deniability. Well, you Indians were fighting against each other too. It wasn't like you guys didn't. So I'm wondering at this level, is there a possibility? I'm not.
They're going to set up alien wars, fake alien wars to blame,
or just anything that polarizes us, right? Because
Right.
that's good for them. It allows them to sell, the Viagra, right? I mean, something that attracts attention that's almost impossible to disregard. I mean, anybody who's curious and knows what an alien is or has seen an alien, we've seen so much, but. I don't know. I mean,
I don't know either. I feel like if they kept it a secret for 80 years, that's very fascinating. And if it is real, also very fascinating. But there's just something about the way this is all being discussed that just feels fake. Mm-hmm. And I don't know why. And maybe it's real. Maybe it is just my natural reaction to something that is so outside of the norm that I don't have a context for it. I don't have a place for it.
There might also be, there's a religious component to it.
There's a religious component to it. Space Daddy.
It's like, the simulation hypothesis, right? This is another one that people just look to, and they act as an explanation why we don't have free will, because they don't want to be held to their accountability. I always say to these people like Sam Harris, like, who doesn't believe in free will, I'm like, have you ever met someone, I don't know, have you ever met someone who acts as if they don't have free will? I'm not talking about someone who's insane. Like, imagine Sam Harris, like totally rational, reasonable, brilliant, intellectual person. But like him, he's like, I don't believe in free will, therefore I'm going to act in accordance with that belief. I've never met somebody like that, like who acts like I'm determined to do this because of the Big Bang.
Well, I think it's a complex or complicated scenario where you're trying to say that determinism is the only thing that causes people to do things, and that you're not responsible, or you're not necessarily saying you're not responsible, but that you have no choice. That there's these factors all play a part of it. And that seems like you have a lot of choice. It seems like we encourage choice in the right direction. We discourage choice that we feel like is in the wrong direction. It seems like it's there's a part of us socially, collectively as a group that wants the right choices to be made because we know that people have the ability to make decisions.
Can I ask you a podcast question?
Sure.
So you've done 2,040, 30 something, Jamie?
Yeah, more than that when you count Fight Companions and MMA shows. Yeah.
So have you ever gone back and listened to
No.
Okay. So this kind of dovetails with what something Carl Sagan said. He said a book is magic because it allows the voice of a person who may have died many, many centuries earlier to communicate with you, and literally with audiobooks, like literally in your ear as you are with millions of people around the world. And I've just wondered, because I never go back and listen to my podcast.
I've listened to it. I should not lie. I've listened to a couple because it was a Graham Hancock one, and I wanted to reabsorb some of the stuff that he said, or someone was just really interesting.
Yeah, sure. But
it's
what
rare.
What I'm getting at is, running a book and like encapsulating that. I mean, surely you've thought about it, and I'm just wondering. A book is something different. It's really the operating system of humankind. Whereas audio is incredible, but like, what are the odds your great grandkids are going to listen to, a preponderance of it versus the distilled wisdom of Joe Rogan, put into a book form for posterity?
No, I've definitely thought about doing that. I'm just very busy. It's hard to take the time to write a fucking book. I'm not going to get any help.
No, I don't mean a ghostwriter. I just mean people to like research and like, this thing thematically, it would all be you, but it would be.
Yeah, I don't know. Maybe I've bandied it about. Just I'm trying not to overload. I think people get a little too ambitious, and I've been guilty of it myself.
How so?
Like just doing too many things. Like I do enough things. Like slow down.
What
concentrate on the things I do more.
What gives you the most life or most like energy force?
As far as occupations?
Mm-hmm. No, all these things that keep you busy. But what's your what thing causes time to pass such that you're in a flow state the most?
Oh, I don't know if there's any one thing that does. I think it's just all the different things. I'm very fortunate that I have a lot of different things that I like to do. In terms of occupation, and I have a lot of great people in my life in terms of family and friends. So I'm very fortunate in that way. But they're all interesting in their own different way. I think they all complement each other, and that's one of the things that I like about doing podcasts and doing stand-up and even doing UFC commentary. I think they somehow or another they complement each other.
That's amazing. Do you ever, when you do stand-up, I was able to do a TEDx talk a long time ago. And before I did it, I wanted to get the experience of bombing on stage in front of an audience of possibly hostile people. So I went to the Comedy Store in La Jolla, and I did a set. And I only wanted to do it clean because my wife and my rabbi was there. Yeah. So I did it clean. I had some good jokes, I think, that I could work on the audience. But it was after 7 women talking about how they menstruate. This and I was the only one that did these.
Was it an open mic night?
It was open mic. Yeah, it was just 2 minutes set. I was the last person to go. When I used my A material. But anyway, we came out, and afterwards I was like, you know what? It was enjoyable. I'm glad I did it. I could say I did 2 minutes of stand-up. But I didn't like the people in the audience. You know, they were, they were drunk and like whatever. I mean, I like my wife was there, but my cousin.
Well, it's open mic night, first of all. A lot of maniacs are in the audience. Like, who's going to watch some amateurs do stand up?
No, I know.
If you have a certain amount of time with your day, how many people are going to go watch amateurs do stand up?
I guess I just felt like this. Like, I never felt like I didn't like my students. Like, I never felt, and I'm sure you don't feel like you don't like your audience of podcasts, but do you ever, when you're doing stand-up, it just seems like there's people in there. First of all, there are people in there that want to see you like mess up or heckle, or not you, but I'm saying a comic.
Sure, at a comedy club, for sure. And especially at an open mic night. Yeah, it's the dregs of humanity.
Yeah, exactly.
And on top of that, a lot of people that are there because they want to do comedy.
Exactly.
So you're doing stand-up to other wannabe comedians. Some of them they're out of their fucking minds.
Right.
Well, not some of them, like a good chunk.
Right.
Yeah.
And I guess the last couple of podcast questions, if you'd indulge me on them. So, you know, when I think about, you know, the kind of animating impulse for me to do what I'm doing and trying to do, you know, hardcore science and keep people interested and engaged and give the public some ROI and their money that supports my salary. I'm a public, you know, I went to public college, you know, schools. I went to public. I teach at a public school. You know, when I think about it, like it's difficult to get a sense of you know, pleasing your audience and then also, you know, doing legit science. And I think, you know, finding that balance for me, that is hard for me. And I don't know, like, I mean, obviously one solution is stop podcast. I mean, I'm not going to stop being a scientist because it's who I am. It's physically written into my DNA almost.
Why would they be incompatible?
I guess, you know, it's like I could always be doing real science. You know, I could always be, for every hour I'm reading a book of a guest that's coming up, I could be doing an hour with, you know, in the laboratory. And so,
right, but don't you, we've already talked about that what you're doing is very beneficial. And you think that that's actually part of what scientists should be doing.
I think they look down on it. Right.
Some of them look down on that?
Yeah.
Yeah, don't listen to them. Fuck those people. There's always going to be people that are, you know, purists, and there's always going to be people that have negative comments.
Yeah.
You should only read so many things that people have said about your work.
Yeah.
And I think you get to a certain point in time when you're oversaturated and then you get overwhelmed. And I see that happen with a lot of people. I see that happen with a lot of people that come from academia and then they get into podcasting and they get overwhelmed, and it's very disheartening.
Yeah.
But you're just dealing with insane numbers. So of course you're going to have a lot of negativity.
Yeah.
There's no ways around that. It doesn't matter what you talk about.
Yeah.
I've seen some of the most fucking insane takes on some of the nicest people ever. It's just you can't do anything about that. There's certain people that have their, and that's fine. That's part of the way the world works. I don't know why certain people like certain kinds of music or certain kinds of art forms. It's just like people like different things. And when you're talking about whether it's science or comedy or what, you're going to have people that don't like what you do. That's just how it goes.
And if I could do my last question, because I'd love to have you on my podcast, but I don't know if that's ever going to happen. So we're going
to talk about aliens the entire time.
I would love it. That would be my bread and butter, man. I would kill. I'd be number 10 on Spotify.
Yeah.
So I always ask the following question, which is related to the name of the podcast I mentioned earlier. So Arthur C. Clarke had all these quips, and some of them are really funny. One of them's like, for every expert, there's an equal and opposite expert.
That's true.
And he would say things,
especially paid experts.
And this famous quote of any sufficiently advanced technology is indistinguishable from magic. And then the name of my podcast comes from his statement that the only way to determine the limits of the possible is to go beyond them into the impossible. And I always phrase that in terms of your 20-year-old self-advice. So like if you were going back to Joe and, you know, back then you're 20 years old, you know, you had 30 seconds with him. What are you going to tell him?
I ain't going to tell him shit. I wouldn't tell me shit.
Why?
I wouldn't tell me nothing.
Why?
Because you figure it out on your own. There's nothing I could have told him. You need life, and you need a bunch of people that you interact with, and you learn. And you keep absorbing information, and you keep trying to do a better job at being a human being, and you get better. But you're going to have to go through it. There's not a goddamn thing I can say to my 20-year-old self like, wow, this is the magic thing. Like, it doesn't exist. It doesn't exist. It's a grind. It's not like a Willy Wonka golden ticket. Life is a grind. It's a great grind. It's a lot of fun. And if you have a lot of fun friends, you can really enjoy it. But progress comes incrementally with a lot of fucking work, and you're gonna have a lot of heartache, and there's gonna be a lot of heartbreak, and there's gonna be a lot of disappointment, and then there's gonna be a lot of great moments. And the great moments, don't dwell on them too much. Like you gotta figure out how to not get intoxicated by great moments and just enjoy it as part of the process. And then just keep trying to do whatever you're doing. Whatever it is you're trying to do it. Whether you're trying to do science or whether you're trying to do art, whatever you're trying to do. That would be, if I give any advice, it's just like, don't expect to hit the lottery. That shit is not coming. And don't expect the fucking golden age of retirement either. Don't think you're going to get to 65 and one day I'm going to quit and then it's going to be amazing. I'm going to sit in my porch. No, you're going to die. Yeah. That's what happens to people when they do that. Then they have nothing to do. Yeah. They get sad. They get sad and they get bummed out. Just enjoy it. Just enjoy this fucking thing.
Would you want to live forever?
That would be the scariest thing, would be doing it all over again. Not living alive forever. Because if you just were like, if I had, like, look, I love life. Mm-hmm. I have a great time. If someone said you have to do this forever, I wouldn't be terrified to do it. Like, why not? Mm-hmm. It's fun. So you're saying I keep doing fun things do I keep getting better at stuff? Because if I can keep getting better at stuff, as long as I don't physically deteriorate too much, and I can keep getting better at stuff, that would be fun. I wouldn't hate it. Just like I don't want to die now. Like, why would I not want to live forever? Like, it's a kind of weird sort of way of looking at it, because both of them are equally terrifying. Yeah. The idea of living forever is terrifying, and the idea of dying tonight is terrifying.
Yeah, I mean, I always see these guys, Brian Johnson, these guys that are trying to extend their lives. I'm like, you can live forever. It actually is possible. Anybody can live forever. But you can't be a greedy SOB. You can't be greedy and want your body to come with you, and your money and the denial of death is why they built these pyramids, right? So
is that real though? We don't really know why they built those pyramids.
Well, yeah, I don't know. You know that each pyramid has a base. The base of each pyramid, Joe, is an exact integer multiple of pi. Did you know
Yes.
that?
Yeah.
Okay.
I did know that.
Do you know why?
Why?
Because what they would do is they would measure back then, like a surveyor, they'd measure the distance with a wheel that would roll, and the wheel has a circumference equal to pi times its diameter. So they would get some number of wheel rolls, and that's why the circle was their measuring tape, basically. So they would just count off how many complete revolutions of a circle. So
is this theoretical? Or is this
that's what they believe, yeah. No, this is the best evidence.
There's a lot of like weirdness to the pyramids. Just the mass alone. There's the 3 million or 2,300,000 stones.
It was the biggest
Some of
thing
them
until
from hundreds of miles away.
I know, it's nuts. It was the biggest thing until the Eiffel Tower.
Have you ever looked into any of that Younger Dryas impact theory?
Help me.
This is the theory that coincides with the end of the Ice Age, and it's also backed up by core samples, where they believe that Earth was hit somewhere around 11,800 years ago, and that it all over Earth was hit with a comet storm. That we went through a barrage of large objects, and it destroyed civilization, and that there was an advanced civilization in Egypt and in many other places where there's actual physical evidence now.
Mexico.
Yeah. Well, physical evidence now, Turkey and Göbekli Tepe, because back then they had thought that 11,000 plus years ago it was just hunter-gatherers. Right. But then they found this Göbekli Tepe did you know about that?
No, I never heard of that.
It's fascinating because it's like very complex stone structures that are immense, and they have 3D carvings on them, which is very unique. And they have lizards, but the lizards are 3D on the outside. It's not like they carved into the stone. They carved the stone around the lizards, and these fucking immense structures. And then they've only uncovered 5% of them. With LiDAR, they've found so many more of them. That's what the 3D carved structures look like. So they carbon dated all this stuff because it was purposely covered somehow or another, and they don't know who or why. But it was purposely covered somewhere around 11,000 plus years ago.
And they think it was a comet? I mean, that would seem to have astronomical evidence for it.
No, the comet thing is 11,800 years ago.
Okay.
That's when, and they think again somewhere around 10,000 years ago as well. But it coincides with the end of the Ice Age, and it also coincides with... there's a lot of evidence of iridium when they do the core samples, in that area.
The element?
Yeah, and then also nanodiamonds from impacts. Yeah, so
interesting.
It's very fascinating because it just speaks to maybe civilization. Maybe this isn't just this emergence from Genghis Khan to us today. Maybe there was a reset, and maybe many thousand years ago, these people that built these structures,
Some people say the lizards are like aliens.
No, there's no alien lore in
Cool.
this. This is just humans that had
archaeology.
reached. Yeah, just humans that had reached a very advanced state and then got hit. But it wasn't until like this Younger Dryas impact theory that they had all the physical evidence that goes with this. And when Randall Carlson discusses this, it's very crazy because he talks about just the immense amount of water that moved through North America in a very short amount of time. It just carved massive trails and canyons through the earth, and he thinks it happened because of an instantaneous meltdown from asteroid impact.
Oh wow! Yeah.
Because we know that the U.S. Alone was half of it was covered in more than a
Submerged,
mile-high sheet of ice.
Yeah.
Up until that point, and he thinks that's what caused it.
I see.
And so it coincides with physical evidence through these core samples, and there's a bunch of like legitimate scientists that are working on this.
Yeah.
It's really interesting.
No, it sounds. I always say astronomers are kind of like space archaeologists. Things travel through time and space, and we have to analyze them. And
It's really fascinating stuff.
they don't have to deal with the multiverse and with archaeology.
Well, listen, man, April 8th.
April 8th.
All right, we're going to go check out, and you say it's going to be more insane than that.
It will blow your mind.
I'm sure it will, and I really appreciate you. And thank you very much for the meteor and the shitty magnet and the good magnet and the stickers and the prism. This is dope.
Happy
thank
birthday,
you. Thank
man.
you very much. I really appreciate it, and I appreciate your time.
Thank you for having me,
And then
Jeff.
tell everybody how to get your podcast as well.
Oh, well, so the best place is briankeating.com. That's my website, and I have links to Spotify there. It's called...
There it is. Look at you handsome devil.
Thank you, my brother. Then, there's our friend Eric, who we didn't talk too much about. Yeah, he says he sends his best. I talked to him today. And I've done it 14 Nobel Prize winners, 15 by
Beautiful.
Friday. And,
Beautiful.
briankeating.com.
And they're very good. Thank you very much for being here. Appreciate you. All right, bye, everybody.